Now I request Rajurkar ma'am to kindly felicitate President sir. Sir, ma'am. Okay. I request Dr. Kanade sir to felicitate Rajurkar ma'am. I request Sachin Savant sir to felicitate our dynamic principal Kanade sir. I again request Sachin Savant sir to felicitate our vice principal Professor Kiran Chaudhary sir. Thank you all of you. Now we will be continuing with our program.
Thank you so much. To begin any auspicious ceremony, lighting of lamp is our tradition. To welcome our guest is our tradition. But our ISS meet has one more tradition that our Pune chapter members have composed one ISS Geet. We always begin our meet with this ISS Geet. So I request to kindly display this AV audiovisual display of this ISS Geet. Kindly do so.
विश्लेषण विज्ञान हर शाखा में है योजित विज्ञान का है ये संगम विचारों का का आरोग्य खेती जल विज्ञान ऊर्जा अवकाश पर्यावरण विज्ञान आदि विषयों में काम किसान चाहे शाला में लड़का सबका ज्ञान सबका गतिशील स्वभाव इसमें जान किसान छात्रों शिक्षक शास्त्रज्ञों का निर्भरता का खिला ये बढ़ता रहा है बन जाएगी बन जाएगी
Thank you so much for displaying this audiovisual film. May I request the pillar behind this meet, enthusiastic and dynamic lady, Chairperson ISS Pune Chapter, Editor-in-Chief Journal of ISS, Honorable Dr. Nilima Rajurkar, for giving information about this ISS and motto behind today's meet. Please, ma'am.
Thank you, Manisha. Very good morning to all of you. Today, Chief Guest, Honorable Respected Patil Sir, National President and Advisor of Journal of ISS, Dr. Radhasaran Sir, Honorable Lande Sarji, Principal Candidate, Vice Principal, invited speakers, sponsors, and dear participants. It is my pleasure to welcome you all for today's meet. First, I will brief about ISS. So, Indian Society of Analytical Scientists was established in 1983 at BRC, Mumbai. And now we are having 10 chapters all over India, having more than 3,500 members from different disciplines. Our Pune chapter was established in October 21, and its aim is to reach all sectors of the society and promote science and technology. So we are achieving this by organizing several lectures by eminent scientists, doctors, from industrialists, and so on. In addition, we are conducting several programs for the UG and PG students, such as quiz competition, e-poster competition, lecture competition, and so on. And we have undertaken an initiative to bring out the different nuclear analytical techniques in the form of booklets. We already published 2 booklets, Nuclear Analytical Techniques and one on nanosynthesis, and we have very good response from all over India on this book. So these books will be displayed at the registration counter. You can have a look at it. And we also organize several theme-based workshops, seminars, etc. So today's is one of them on interdisciplinary approaches in analytical sciences. I'm happy to mention here that our chapter has received Best Chapter Award for consecutively 2 years, and many of our members have received several honors and awards from ISS. Now about Journal of ISS. So Indian Society of Analytical Scientists started our own journal named as Journal of ISS in July 22. So this is the second anniversary of our journal. It is a quarterly e-journal, which is open access, having ISSN as well as DOI numbers. And we have original research papers, short communications, then we have case studies, reviews, etc. So up till now, we have published 8 issues, and today, which will be released, is the 9th issue of this anniversary issue. So that will be released after some time. So this is in short about our journal. I invite all the participants who are presenting the posters here and other researchers also to communicate your valuable work to our journal. And this issue, next issue, will be published in October. So you can communicate your papers by mid-August, so that it will be peer reviewed and all these things by usual procedure. One of the thing is we are having very fast publication. There are no any charges, free access to all. Okay, so I welcome all the participants and enjoy your scientific feast today. Thank you.
Thank you so much, ma'am. May I request Honorable Principal Dr. Kanade to kindly introduce another dynamic personality, pleasant personality, Honorable National President of ISS, Honorable Dr. Raghav Saran.
Good morning once again, Dr. Raghav sir. Is it audible to you? Please. Is it audible? Okay. So I am happy to introduce the inaugural guest, that is President of this ISS, Joint Atomic Material Director for Exploration and Research in the year 1969 after his PG from Allahabad University. He served as a AMD in different capacities in almost all the regions throughout the India. He was responsible for setting up mobile laboratories for on-site, always almost first time in the country for the exploration of atomic minerals received under UNDP in the field areas or different parts of MP and NER. 1-ton uranium extraction project plant at Domeset, NER, Meghalaya. He was also responsible for setting up base and field laboratories in several regions of the directorate and was awarded 3 times from the department suitable. Completed his PhD from Guwahati University during his posting in NER in 1995. He is the fellow of several societies such as Institution of Chemists, Indian Chemical Society, ISAS, besides being life member of INCS and REAI. He was awarded in 2013 as the IBC leading scientist of the world. He is instrumental in founding several chapters of ISS since inception of the society in 1983 and several ISS in different capacities. He has organized about 12 to 13 national and international symposium, latest being International Analytical Science Congress 2024 with the theme Analytical Sciences and Technology. That is the futuristic trends for energy, environment, and sustainable development at Nagpur in the February 22 to 24, 2024. He is also chairman of advisory board of Journal of ISS. He has been work as a 35 years in the analytical geochemical explorations of about 70 elements, the atomic interests such as uranium, thorium, beryllium, neodymium, tantalum, and many alkali metals, rare earths, and associated with these particular the research. Right from the basic analytical days of the latest plasma-based, nowadays students, they may notice that the plasma-based technology for that is semiconducting and nowadays that is the recent the burning area regarding the pattern for this electronic industry. So he was one of the pioneers of the derivative spectroscopy and non-aqueous flame AS in geochemical analysis. He was involved in methane budget estimation during 1990. R&D. He has 113 peer review paper and also he presented over than 50 research paper in the national international symposium in the country as well as abroad. He is a recognized PhD guide for Guwahati University and also IIP Dehradun. He is a former visiting professor Guwahati University. Currently, he is an adjunct professor in Arshio EM Nagpur. His latest book is Analytical Techniques for Trace Element in Geochemical Explorations. It was published by Royal Society of Chemistry in the year 2033. So this is very, that is the intelligent that profile and CV of our inaugural guest, Dr. Raghav Saran. Thank you very much.
Thank you so much, sir. May I request Honorable National President of ISS, Dr. Raghav Saran, to kindly address the audience. Dr. Raghav Saran, sir, please.
Good morning, friends. I'm so happy, highly delighted to meet you all. though some of you had already met online in our webinars, some at Nagpur too in our International Analytical Science Congress in February, but meeting you in person and many of you, it's really remarkable. Dear students and several distinguished dignitaries like Professor Patil, uh, our Honorable Dr. Lande, Founder President, Principal Dr. Kanade, and Vice Principal Dr. Chaudhary, and over and above Dr. Nilima Rajurkar, Chapter Chairman of Pune Chapter. So it is heartening to see the huge response over, I think, 100 poster presentations at such a short notice. Presence of August gathering adding value to the second annual meet of journal ISAS. As you already know, our quarterly e-journal with ISSN for the journal and DOI assigned to each published article gives it a worldwide recognition. ISAS, since its inception in 1983, had an idea of publishing a journal to bring out the latest research to the scientific community so as its basic purpose is served, service of common man. But unfortunately, during those days, facilities were very much restricted as compared to present. The attempts remained sporadic, something sort of newsletter with a few research articles. Printing cost to imposed constriction, and slowly the idea became dormant. But it again came up with friends with similar thought in 2022. And we got all ready by July month to come up with the journal. We were almost ready for inaugural function, but we came to know that the earlier name decided, Analytica India, was already registered. God, you can think well that what would have been our situation. Lot of thought churning just revealed that no other name may be safe because any name might have been registered. We can't be sure of that. So ultimately decided to use a name which is already with us and it is registered also. That is nothing else but ISAS. And so the name decided was Journal of ISAS. And see, today we are here celebrating the second annual meet of the journal. Matter of happiness, isn't it? Yes, but it will be happier if you all take it up with equal zeal, zest, and vigor. Make it your own journal and contribute your research articles, your students' research articles, your friends, your colleagues, whosoever comes in your contact. If they contribute to the journal, then to the optimum level, so that just like ISAS, with around 4,000 members and 10 chapters all over India, JISS too becomes strong, especially when each published article has its worldwide recognition in the form of DOI. So it's not very essential to go for Scopus index and all that because it is already recognized. You already have a DOI, digital object identification. So that means you can very well go for the journal. On the occasion, one day symposium on a very relevant topic is organized. The theme interdisciplinary approaches in analytical science is highly relevant. Overall, Analytical chemistry is a fundamental discipline that intersects with various branches of science and plays a critical role in advancing scientific knowledge, technological innovation, and social progress. Analytical chemistry, chemical analysis, and analytical sciences are intricately interwoven. The unstinted dynamism of analytical science, with growth in optics, atomic and molecular spectroscopy, electronics, programming, softwares, and computer sciences, led evolution in analytical sciences. Supplementing the classical empiricism of earlier era into a newer chemistry involving DT and NDT, that is destructive tests and non-destructive tests. Gravimetry was followed by different type of titrimetry, formation of colored complexes, colloids, turbidity with suitable ligands, color imparted to flames by elements, fluorescence, phosphorescence, formed basis of molecular and atomic spectrophotometry, molecular and atomic fluorescence, eyes replaced by spectrometers using prism, grating, and their combination. So that's why we always ask that we are ISAS, Indian Society of Analytical Scientists. It does not mean that it involves only chemists. It is chemistry, physics, computer science, electronics, and all branches, chemistry and technology. Without technology, a device cannot be manufactured. So technology is an important part of it. And whatever we do, whatever research we do, that research is for actually common man, only for the service of humankind. Otherwise, it's of no use. See, only one reagent you remember, Grignard's reagent. Now, just one reagent he has prepared, and for that he got Nobel Prize. Why? Just because that was of human utility, utmost human utility. So, and similarly, and a lot of developments took place. As a matter of fact, LPG flame earlier was used, and that was replaced by air acetylene and nitrous oxide acetylene flame. Inductively coupled argon or combination of argon and nitrogen plasma, evolving flame AS, HRCSAS, HRCSAS, and hyphenated techniques like graphite furnace, atomic absorption spectroscopy, vapor generation, concomitant metal analyzer, that's something like hydride generation, used by along with ICP-OES. In addition to electrochemical processes like DPASV, you already know differential polarography, anodic stripping voltammetry, and DPCSV, cathodic, ion and other chromatographic techniques. NDT involve actually X-ray spectrometry, XRS, energy and wavelength dispersive, EDS and WDS, both. Electron probe microanalysis, EPMA, different types of mass spectrometry, such as isotope dilution, IDMS, resonance ionization, glow discharge, mass spectrometry, GDMS, sputtered neutral atoms, SNMS, laser ablation micro mass analyzer, spark MS, secondary ionization mass spectrometer, nuclear analytical techniques. If I don't mention, it will not be complete at all. Gas chromatography, mass spectrometer, X-ray and synchrotron devices, and other non-destructive structural kinetic and other techniques. ICP-MS with different improved versions like ICP-TOF-MS, and then HR ICP-MS, ICP-QQ-MS alone are coupled with vapor generation or electrothermal atomization. Besides the portable PXRF, that's portable is P, and that is nothing but EDS, energy dispersive. LIPS with suitable care of sampling and statistical treatment of data with proper analytical quality assurance. If statistical treatment of data is not there, the reliability is not at all proved. So, analytical quality assurance and analytical quality control measures, leaving behind several destructive techniques. The advances have brought down the earlier concept of determination limits of trace elements to ppm to ppb. Now we are talking of ppm to ppb and sub ppt also, parts per trillion level in several cases. The sample size, now slowly, it continues to shrink. Instruments get miniaturized, sample preparation devices and microfluidity improves, eventually culminating a lab on chip technology. The growing role of analytical sciences and its prominent role in multifaceted fields such as geochemical exploration, etc., 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 semiconductors to food, forensic science, petrochemicals, weaponry, consumer products, process management and automation, particle sizing, beveraging, glass and ceramics are, in brief, analytical sciences are very inextricably interwoven part of the entire gamut of science and technology activities encompassing all sectors of development. My congratulations are due to the untiring efforts of each member of organizing committee and vibrant subcommittees, the real pillars of success behind any program, and of course, behind the second annual meet of the journal. I just don't want to name them because missing a name would be injustice, but can't remain without mentioning the key name whose sheer determination, grit, strife, stellar performance keeps motivating the team on right path to move on. Sure, you all know. I think I need I say? Can you say? Our editor-in-chief, Dr. Nilima Rajurkar. Clap for her. So congratulations, Nilima, for the entire outcome. I'm sure you will derive benefit from the talks by the specialists with expertise par excellence in their fields, a fruitful exchange of your research through your posters, variety of your posters would create awareness about the work going on. I wish a very successful meet and all the best to each one of you. Sincere thanks for patient hearing. Thank you. Thanks to you all.
Thank you so much, sir, for addressing our audience. And surely they will take the message from Saran sir that science without technology is useless. So all teachers and students present over here surely will remember this when they do research, that science without technology is really useless. Thank you so much, sir. On behalf of ISS Pune chapter, I request Dr. Nilima Rajurkar to kindly felicitate founder president of RJSPM, Honorable Shri Vilasji Lande sir. The ISS Pune chapter would like to felicitate Lande sir. So kindly accept our token of love. I request ma'am to kindly felicitate our chief guest, Honorable Dr. S.F. Patil sir also. तुम्हीच करा, मग मी अनुपाला बोलवते. I request Dr. Anupa Kumbar, the convener of this meet, to felicitate our dynamic Raghav Saran sir. Thank you so much. Thank you, Anupa. Dear friends, I am here now to introduce today's chief guest, Professor S.F. Patil, sir. I'm really honored to introduce this great personality. Dr. S.F. Patil, Professor Dr. S.F. Patil stands as an paragon of educational excellence, seamlessly blending roles as an esteemed teacher, eminent researcher, visionary educationalist, adept administrator, and committed environmental advocate. His multifaceted contributions have earned him distinguished fellowships, including that of Maharashtra Academy of Sciences and an honorary fellowship from the Indian Society of Analytical Scientists. Guiding 36 research students for their MPhil and PhD degrees, Professor Patil's mentorship has spanned the intricate domain of nuclear and radiochemistry, electrochemistry, environmental science, and nanoscience. His scholarly outputs is profound with over 200 peer-reviewed publications, gracing both national and international journals. Professor Patil's expertise has not gone unnoticed on the global stage. Prestigious institutions such as the University of Bremen, East Anglia, Cambridge, and Cornell have sought his sites, extending invitations for him to serve as a visiting faculty. At Pune University, his leadership catalyzed significant advancements within the chemistry department and at the university level, and later at the second vice chancellor of North Maharashtra University. His spearheaded spearheaded the introduction of innovative courses, enhanced infrastructure, and improved universities' operational efficacy. A staunch environmentalist at heart, Professor Patil's initiative to plant 98,000 teak plants at North Maharashtra University underscores his dedication to sustainability. His tenure as Vice Chancellor at Bharati Vidyapith was marked by pivotal developments, including launch of cutting-edge courses and the establishment of campus in Dubai. Nationally, Professor Patil's acumen has been recognized through his roles as chairman and member of National Assessment Accreditation Council, that is NAC, president of Association of Indian Universities, and other prestigious positions. His international engagement include leading delegations of Indian University vice chancellors to Syria, France, and Australia, where his efforts facilitates significant academic collaborations. Throughout his illustrious career, Professor Patil has been adorned with numerous accolades such as Professor M.V. Ramanna Lifetime Achievement Award by Indian Association of Nuclear Chemists and Allied Sciences, Professor Frederick Joliet Curie Endowment Lecture Award by Pune University, and Jeevan Sadhana Gaurav Puraskar by Bharati Vidyapith. These honors are a testament to his profound impact on academia and beyond. Professor Dr. S.F. Patil's enduring legacy in academia, his pioneering research contributions, and his unwavering commitment to education, reforms, and environment stewardship continues to inspire a generation of scholars. With this brief introduction, may I request Honorable Professor S.F. Patil, sir, for his inaugural speech. Professor F.S. Patil, sir.
Thank you for your kind introduction, which is not required so much to be given. I am here to, actually I was supposed to be chief guest of this function, but as usual, I have been given responsibility to inaugurate the session. To begin with, National President of ISAS, Professor Saran, chief guest of today's function, Dr. Acharya, Head Isotope and Radiation Application Division, BRC, Professor Ajurkar, Chairperson of the Pune chapter and the Chief Editor of the journal, Dr. Kanade, the Principal of this particular college, and most importantly, Dandes are the president of our institution, who has been found time to come and inspire these young people here. Dr. Dapegawkar, Jinjarek, Dr. Bakash, faculty members of the institution, and my dear young students, ladies and gentlemen. At the outset, let me express my gratitude towards the organizers for inviting me to be a guest of honor as well as to inaugurate this particular function. Friends, I don't know what I'm supposed to speak, but I think I will speak about the analytical chemistry as such. It's well known, all of you know, that without analytical chemistry, nothing can progress in any branch of science. It has a paramount importance, not only in the branches of chemistry, but also in biological sciences, engineering, and more recently with environment, health, public health, medicine, and energy sectors of all types. Scientists and technologists have a great job to do. They need to establish the identity of materials, quantify their composition, express their purity, and measure the contamination to the level of fractions of or tens of nanograms per grams of the substance. As you all know, the analytical chemistry is a measurement science consisting of set of powerful ideas and methods that are essential for all fields of science and medicine. Analytical chemistry helps science and technology to solve the practical problems of the industry. As you all know, it's a central science and has developed tremendously in the recent years. If you remember the development of analytical chemistry when we were students, somewhere in 1966, we didn't have the instrumentation at all. For getting a TGF sample, we have to go to NCL, and that too only on Saturday and Sundays. TJ is now so common in those days. So I work in the field of nuclear science. Many of you will probably be surprised to know that with 7 students, PhD scholars, we had only 1 liquid counter. And now you guys, you new generations are so lucky that you don't have to do that much hard work. We used to work for 8 o'clock to 12 o'clock in the midnight, and now you guys simply put your samples in sample changer, just switch the button, repeat 10 times, and you get much more accurate results than we used to study for months together. I think that's why I said the analytical chemistry has made tremendous progress in the field of science. Now, this modern chemistry can be defined as a science that develops methods, instrumentation, and strategies to advancement in every branch of science. It is now essentially become a multidisciplinary subject encompassing all branches of chemistry, physics, electronics, engineering, computer science, the many other fields like automation, robotics, and others. It plays a critical role in understanding the basic sciences and the variety of practical applications ranging from geology, agriculture, pharmaceuticals, biomedical applications, environmental monitoring, quality of control of industrial manufacturing, forensic science, archaeology, space science, and whatnot. A large number of analytical techniques are now available. As I said, nowadays we never heard the HPLC, MS. I still remember that when the first GC came to Pune University Chemistry Department, we were supposed to be one of the top universities in the country. We all were so excited. Yes, we got it from BRC in those days. That we had a good relationship. But now I think the HPLC GC has become so common. Now you have gone NMR, IR, IPSS, SEM, HPLC MS, HPLC MSMS, GC MSMS, we never heard of in those days. And so this analytical chemistry has provided several advancements in each branch of sciences. Now it is routinely used, but choosing a particular technique, one has to consider several aspects. And for that, what precision you require? what accuracy you need in this case. What is the sensitivity of that particular equipment? What is the specificity of that equipment? Matrix effect, non-destructiveness of nuclear, particularly nuclear science. The multi-dimensional capability. Now, activation analysis, if you see that Rajurkar madam has contributed a lot, and probably I happen to be her guide. So I also got the credit that starting the activation analysis. We could do now picogram level, not only one element, I have simultaneously 70 elements, which we couldn't imagine in those days. So I think the technology has definitely helped in advancing not only the science, but also the industrial development. Nowadays, the miniaturized concept of instrumentation has come using chips. And this revolutionized our analytical chemistry from macro to sub-micro to ultra-micro to even single molecule. I think to imagine a single molecule or single cell was probably 50 years back was not believable. I'm pleased to note that Indian Society of ISAS, all the scientists spread over the 10 chapters are contributing, playing a major role in promoting the excellence in right direction, both in routine and innovative work. I am particularly happy that the Indian chapter, which was established 3 years back, has done a commendable job by taking several activities and popularizing ISAS. I think Dr. Rajukar is a very dynamic personality, but whenever she decides to do it, I remember not only as a colleague, but even as a student, once she decides, she will do it very successfully. I'm sure that under her leadership, a chairpersonship, as well as the chief editorship of the journal, it will progress ISAS in much bigger way. Dr. Saran Saab, I always wonder, why do you take so much time to establish a chapter at Pune? Well, I think Pune has got all the facilities, national institutions, 15 universities now. I think I really wonder why ISAs did not really concentrate on Pune. Anyway, but I think we were right that among the several chapters, the Pune is doing reasonably well, as has been evidence that they got 2 times the best chapter awards at the national conferences. It's my great. I'm very grateful to university for inviting me to be here, and I think it's my honor and privilege to inaugurate the ISAS Journal Meet, which is now celebrating the 2nd anniversary, with the theme of multidisciplinary approaches in analytical chemistry. I hope we will have a very fruitful discussion. And all these youngsters will get inspired. And I do request President and the principal to become a more member of ISAS so that they will also get sort of exposure to latest techniques in the analytical chemistry. Thank you very much.
Thank you so much for that inspirational inaugural speech, sir. Thank you so much. Thank you for praising the work of ISS and ISS Pune chapter. It definitely motivates us to do a good work. Thank you so much. Moving ahead, we are here for the we go for the journal, right? Release of Journal of ISS. I request Professor Dr. S.F. Patil sir and all the dignitaries on the dais to kindly release the Journal of ISS. So we will be doing so online. As you know, that from COVID, we have learned online and offline blended ways of communication. So this Journal of ISS is getting released online. I wish Journal of ISS already is a peer-reviewed journal. And I request ma'am to give information about it.
Please go to next slide. So this is our cover page. This is our 9th issue. This is editorial board and our advisory board. We have distinguished scientists from all over India in this. Next one. Next, please. Okay, these are the just guidelines to submit your communication with the journal. Next one. So, a message by our president and advisor of Journal of ISS. Next one. This is my editorial. Next one. Next. So this is the content. So it contains this review as well as short communication, then original research paper, as well as case study. So we have all type of communications which are related to analytical sciences are invited. So you can access these freely on our website, issbharat.in. Thank you.
Thank you so much, ma'am, for giving this information about Journal of ISS. Journal of ISS is already a peer-reviewed journal with DOI, and I wish soon we will be entering in the UGC Care and Scopus Index journals. Thank you so much. I request Dr. Raghav Saran sir and all the dignitary on the dais to kindly release the abstract book of today's meet. As you know, students and teachers, you have already communicated abstracts with us, and you will be doing poster presentations today in the afternoon. So this is the abstract book of these research findings. Kindly clap, give big hand for the release of abstract book. Thank you, sir. Thank you so much. Yes, introduction. Well, in the introduction. Yeah. Dear friends, may I request Dr. Santosh Tedare sir to kindly introduce today's guest, Dr. Raghunath Acharya sir, who is with us online mode. So Tedare sir, kindly introduce, please, Dr. Acharya sir.
Okay. Good morning to all the dignitaries present on the dais, all the speakers and participants gathered here for this today's ISS meet. Myself, Dr. Tyardai from Department of Chemistry, Savitribai Phule University. So I'm thankful to Professor Rajurkar Madam and the convener, Professor Kumbar Madam, for giving me this opportunity to introduce today's chief guest. So we all are privileged to have a great personality in the field of radiation chemistry, Dr. Raghunath Acharya as the chief guest of today's ISS meet. So Dr. Raghunath Acharya joined this radiochemistry division of BRC in 1994 after completing 1 year bachelor training course in chemistry subject. He has contributed significantly in the R&D work on nuclear analytical chemistry, utilizing research factors and particle accelerators for the chemical characterization of materials by different techniques. The most important and the proud thing for him is that he is for the first time he has developed and utilized K0 based neutron activation analysis techniques as well as from gamma nuclear activation analysis techniques and in situ current normalized ion beam analysis, which we call as particle induced gamma ray emission technique. He has successfully completed many projects under or funded by BRNS, UGCDA, CSR, as well as few projects under the combined research scheme of BRC and Pune University. He obtained his PhD degree from University of Mumbai in 2000 and completed his postdoctoral studies in Dalhousie University, Canada, in the year 2000 to 2002. His research work has reflected and has, we can say that he has shown his caliber by publishing more than 185 research publications and more than 3,000 conference presentations till date. Presently, he is working as a task force member for utilization of BRC facilities by the university faculties as well as students through UGCDA CSR project scheme. He is a recipient of many awards. To name few, Dr. Tarun Datta Memorial Award in the 2003 of Indian Association of Nuclear Chemists and Allied Scientists. He is also a recipient of Young Scientist Award in 2008 of International Committee of Activation Analysis. and Scientific and Technical Excellence Award of DAE in the year 2009, as well as Group Achievement Award of DAE in the year 2019. Currently, he is an executive committee member of various national and international professional bodies, including INCS, that is Indian Association of Nuclear Chemists and Allied Scientists, ICS, SPAN, including our ISAS. Presently, he is secretary of Indian Chemical Society, that is ISAS Mumbai branch. He is an elected member of K0 International Scientific Committee since year 2009. He is an elected member since 2008 and secretary from 2009 to 2028 of International Committee of Activation Analysis, that's ICA, and editorial board member of Journal of Radioanalytical and Nuclear Chemistry since 2023. Currently, he is also heading the Isotope and Radiation Application Division, that is IRAD department, as well as Radiochemistry and Isotope Group, BRC Mumbai, and he is also professor in Chemical Sciences at Homi Bhabha National Institute, DAE. So with this short introduction, I welcome you all, sir, on behalf of IS Pune chapter for this IS meet. And I hand over mic to Professor Bora for further things. Okay, thank you, madam.
Thank you, Tedai sir. I request Honorable Dr. Raghunath Acharya sir to kindly join us on online mode for his keynote address.
Yeah, thank you. Am I audible?
Yes, sir.
Yeah, just a few minutes I'll speak before I go for my technical presentation. Good morning to all of you. I have seen Professor S.A. Patil. I have seen him, very honorable, who is a Vice Chancellor and is very attached to Pune University and INCAS Lifetime Achievement Awardee, M.V. Ramani Award. So it is very honor. So my first apology that I am not physically present because last night I got a call. I have to be in office after 12 o'clock. Professor Rajurkar, madam, who is my collaborator and a mentor, well-wisher to me, to my family also. Actually, we are supposed to join my family also, but I could not come. My wife is also scientist. She would have been a poster committee. I lost a chance. National President of ISAS, sir. I'm very happy to know that, sir, you are from AMD and so much knowledge. I'd like to have you in BRC. I give a standing invitation to you and Professor Rajurkar to BRC for progress of science and analytical sciences. So I'll be very happy to host you at BRC. And college, RG SPM college principal and also president of the college. So what I do that all the dignitaries and the dais and all the participants present there at the audience. So, you know, it's very, very important, you know, analytical science plays a big role in chemistry, whether it is a material specification, whether chemical quality control materials, all branches, you know, CQC. First is chemical characterization. This is the first step. And analytical science plays a big role when science started. And I do a work in a different area that is called nuclear and radioanalytical sciences, using research reactor, using particle accelerator, whether it is gamma ray, X-ray. And we have tried our best to apply this field to many areas, which I'll be presenting shortly, including ores minerals. That's ISAS president, national president, also very keen. And he mentioned also that without mentioning nuclear techniques, it will be incomplete. Thank you, sir. I clearly mentioned your things. See, if I see quality assurance, quality control, when you give a data, no, everybody wants how accurate you are, how sure you are. Many times we believe the instrument, but we more believe the person who is giving. Usually the authority of the institute asks, who has given the data, whether a student or the JRF or a professor. So it is the instrument and the person. So this is the way it goes. So before we started working in pioneers of a field, you know, like starting from Professor H.J. Arnulekar, Professor B.C. Halder, whether he present is Professor Ian Gorg, Madam Gerard Turrell, In that category, Professor Rajurkar also stands there. So he is always honorable. Recently, she visited to BRC, our nuclear pros meeting. She happily chaired with no cost to BRC. I thank you, madam. And you always support me. So I'm getting emotional because I am not present there. Now coming back to different techniques. See, each technique is important. We never undermine a technique. Let it be gravimetry, titrometry, let it be any like ICP-IS, ICP-MS, which are now workhorse of the analytical sciences. But we always tell, do proper validation, be assured, don't be under pressure of a supplier or a user. Please give me result. Don't compromise on data. Give a data with the highest accuracy, with the highest precision, that is lowest uncertainty you achieve. Do replicate measurement. So I request, because I am not a very, very big personality, but I tell all these persons who are on analytical science, kindly do in your hand, please see the data, validate by other technique, be assured, because your data is nowadays international because of multimedia, journal and social media. Your paper, if you put in your status, it goes abroad, it goes different places. So we are very careful. We are started working on CRMs. India is starting CRM. I am a CRM panel. So I request ISAS to join hands with the Indian Chemical Society, Mumbai branch, Indian Chemical Society. Also join hand with the IONCAS, Indian Association of Nuclear Chemists and Allied Scientists. We work together for society, for industry, for better human life. You may be seeing the life of any student, any persons. You might have seen last night, the persons who are going to be civil servant, IAS, how pathetically they suffer. They stay in Delhi, they stay in different places, and they become the person who lead the country. So our main job is, through our science, we should give quality life to each individual. So that is our motto. So what I can tell and summarize here before I go for presentation, quality versus quantity is a very, very important. Demand versus supply, this is also another thing. So what I can do, we'll do our work, we'll do our karma with good knowledge. You do a duty with good knowledge, and that reduces your time. And also with all politeness, with respect to our all seniors, mentors, who have shaped Indian science, Indian analytical science, with all advice and a mentorship, we can progress well. I have a lot of objective to bring analytical sciences in one umbrella, which will be very good R&D. It is we are working with the principle of RDQ. To start doing research, you develop a methodology or technique or technology, you demonstrate in a proper forum, and then you deploy. RDQ, research, development, demonstration, deploy. So this principle, so we have worked. So I have got 30 years of career. Recently, first time in a radiochemistry division, and first time in our accelerator. We are always R&D persons, but analytical chemistry, they do commercial, but we started a commercial utilization of accelerator. And this is my work. And we had a target of 100 samples per year and boron carbide, which is done by mass spectrometry with a high precision. But I started ceramics, glass, alloys, refractory material, and nuclear analytical technique plays a big role. And there we identified why nuclear analytical technique. Nuclear analytical technique is not another technique. It is a specific technique for specific samples. As received sample, direct sample, no waste, no radiation much spill, and we can do. Even some sample can be done like archaeology, alloys, glass can be done, even we can return. That is our research. We have published many papers. And if any, my address will be there, my email will be there. All the faculties, even students are welcome to DAE at any institute, not at BRC, at different places of India. kind of utilize. DA is for India. It is government of India. It is everybody's place. It's not the place for us. That is our outreach. Today, we are going out, tell people, health, agriculture, food, water, research, quality life, even national security, our institute is working. Please join hands. Many people come from, we are from village, we are from different places. Now we are a DA scientist. Like that way, we welcome everybody. There are different schemes. I can give a lecture after some time. What is the BRC facilities? I'll give you something open for research, free of cost. Do R&D. This thing there. I hope I gave some message which Professor Patel can appreciate. He has seen DA for a close corner, but DA is changing and DA is for all. That is my message. With this, I close here. I thank all organizing committee, particularly the college, that RG SPM college and the national president, Madam Rajurkar, Professor Patil, all organizing members, even our Professor Adhyapak, who is there from CMET, he's sitting there. I have seen him. He might be missing more. So very soon I'll be visiting CMET also, Professor Adhyapak, and all people. Thank you very much. And this is my speech over. Then you tell me what I should do, whether I should present now or you have to close and then presentation. You decide, madam. Thank you.
Then start your presentation.
But आप बैठे उधर you can see. Or you can do vote of thanks and then presentation, that will be better.
Yeah, I think that will be.
So that you can sit in the audience and I can present. नहीं आपका vote of thanks कुछ होगा तो please.
I think you continue your talk, sir.
Okay.
About 30 minutes, yeah.
Okay, I'll be, what I can do, madam, around 20-25 minutes, no, you can sound me. So
Okay,
I can
sir.
close so that I'll not bore you.
Okay, okay.
But I have good material, but I can close. I'm very sensitive. I can close at any.
Okay. You can summarize in 20 minutes, sir, then.
Okay, sir.
Thank you.
25 minutes, I'll finish everything.
Okay.
Thank you, madam.
You can see there.
Others can see, no?
Yeah, others can see. They can see.
Is it visible?
Yes, sir.
Okay. This is my CV. I thought you may not have. So directly I'll go to my slide. I'm happy that Professor Garg is there, so I could not beat him. So I'll see how to keep it. See, the title is chemical quality control of materials. Knowingly I'm keeping, but we do chemical characterization, then called chemical quality control. But I'm keeping chemical quality control and giving that many times we have certified the material fit for the purpose. And the nuclear analytical methods I have used neutron and proton. You know, neutron is non-charged. It can do a bulk analysis and from major to trace element. Proton is a charged particle. It can do surface analysis. And I'll show advantage what neutron can do, what proton can do. So in this case, we always take the advantages of each probe or each technique rather than commenting on its limitations. So in this way, and here you can get my address. If students or faculties can take a photograph so that you can write me, I can be easily available to you for any collaborations, any suggestions. Just for new people, other people, though we are in Maharashtra, still many people have not seen what is DA, what is BRC. 1948, Homi Jahangir Bhabha started atomic energy establishment at TIFR. 1954, it was actually atomic energy Trombay, 8 Trombay, and also DAE, 1954. And after the passing away of Homi Jahangir Bhabha, this institute was named as a Bhabha Atomic Research Center. So as such, Bhabha Research Center, started in 1954. And you should be happy to know, in 1956, we got fast research reactor, which is Asia's fast research reactor. This is India. So as an Indian, we should be proud that India is not really just a country or developing. India is a rich country having a lot of enthusiasm, lot of energy, lot of knowledge. We have got a great scientists, Baba is an international scientist and a great visionary. And that time he gave mandate that we should have energy from nuclear power. We should apply to agriculture, health, industry. We should develop technologies for good human life now, now leisure, computing, all the robotics, and promote research for energy and for national security. So have a good life, a good security. This is the way country should progress. Today, if you see, we have got Atomic Energy Commission, we have a DAE, and we have many R&D centers like BRC, IGCAR, you have many public sector nuclear NPCL, you have industry, heavy water board, BRIT, isotope supply, okay. And in the government also, AMD is there. And service sector also, DC, ACM, all the things there. We have now our own university, Humeva National Institute, where I am a professor. We have a funding body, BRNS, you conference, symposium, you can do. Everybody can apply this. And we have also fundamental research, TIFR, SINP, TMC. Tata Memorial Center is for cancer. TMC is going throughout to India now. This is the best cancer center. DA is funded. And our institute like IOP, other thing, and other institutes. If you just, a bird is flying, how you see Bhabha Research Center? Here is the Arabian Sea, and you are coming from that, everybody might have seen what is Gate of India. Gate of India side. Then you have Elephanta Cave, other thing that is actually Alibag, other places. And here is our New Bombay. And here is BRC, our Dhruva reactor. And here is Cyrus reactor. And here is our garden. And this is modular laboratory and administrative building and all halls, other things. And this side is Apsara U. New Apsara now started 2018, New Apsara. And actually our Apsara, old Apsara was this side. 1956 old Apsara this. Then 1960 Cyrus, 1985 Dhruva reactor. They are all research reactor for neutron isotope production, research and training. All these radioisotope what you get, cobalt-60, Iodine-99, iodine, that is helpful for health or agriculture or the industry. They are coming for our reactor. And this is our new reactor. You can see blue-green light called serum of radiation. This is at 2018. We started during just before Corona. So this is a great institute. So we work here. If you see this environment is a good, very clean environment, good gardening, good facility, good amenities. In that way, we do research. Dr. Homijay Bhangiri Baba was a good painter. He likes music and he was a great human being. Gardening. So many persons still we have a gardeners and many people are working. We always tell but they are also very, very important part of the system. So that is the way progress. This is another view hillside, and you can see Cyrus and administrative building. Here is supercomputer building, computer science. Here is TIFR, BRC TIFR facility. That is a particle accelerator, charge particle. You can get a proton, alpha, other charge particle. And here also you can come and do research. We have a lot of ways. Some other time I can tell you how you can come research, how you can get funding, all the things for your career development. So Apsara U 2018, Dhruva 1985. We have a modular laboratory. We have a Homi Baba Center, our Human Research Development. We are giving MTech, a PhD. We are training our trainees for future, all the things. And there is a Vice Chancellor here. There is a Dean here. We are equal. And we now, I think we are now, I don't know what is the position, but we have got A+ grade, NAC A+ grade, this institute. If you see different group, we have basic science, physics, chemistry, radiochemistry, isotope group. I belong to nuclear fuels, materials group, nuclear cycle group, bioscience, engineering, radiation photochemistry, theoretical chemistry, analytical chemistry, very, very old division, and water stream chemistry, and chemical compositional characterization of materials. That is Hyderabad, we have got a center. Just this is my new division where I'm working. We are working isotope hydrology, water scarcity, water campaign. Our division is very, very expert throughout India. National Water Board and everywhere we are doing. Radio tracer we are doing many applications, and also we have got electron beam and gamma facilities. So all are welcome. This is my new facility where I'm heading for research. This is the facility, you can take a photo. This is the facility open for research from 2021. And these facilities are open for research without any cost. You can come and use, but you need a collaborator from BRC. These are BRC facilities. And here you can see nuclear radioanalytical, where I am heading this committee, spectroscopy, DXR, other things. And positron annihilation also it is there. You can use a reactor, you can do accelerator, you can do analysis. Many good research you can do. So this I'm welcoming you for these facilities. And you know, this photo you can take, these are the persons, the material groups area. Central Director PD Babu, you can write him, you want to come and use facilities. You may get TADA for 1 week with our faculties. Student special permission required. Or even nuclear physics, this person. Solid physics, this person. But now nuclear analytical and radio tracer, I am the person. There is a committee where I am chairing as the nuclear analytical application committee, and also I am member secretary. So I will be the key person to coordinate. Kindly write to me. I'll try my best to bring you for a conference or to make your visit and have a DAE mandate. I'll be working so that DAE for society or nuclear science for society and industry. That is our slogan. Let me come back another 15-20 minutes for the topic that madam has given. Chemical characterization. When you are doing chemical characterization, you have to do that materials fabricated, synthesized, procured. It has to conform to the specification laid by the designer user. So for that, we do some analysis, analytical techniques, whether it is non-destructive or destructive. We do and give the value. And that value needs validation, that is called quality assurance and a thing. But if you see routine analysis techniques are mainly destructive, like atomic absorption, atomic emission, acidness. Now it was thought whether I can do directly analysis without and less sample, more result, like you call that more from less, and whether you can get many informations. So our move was hydrogen to uranium and low Z, high Z, how to do. And I'll show you some research what I have done in BRC. I'll show some research what I have done with Madam Professor Rajurkar. That is my job. Without that, it will not be complete. As you told, already AMD sir has told that techniques start with the primary because all senior people, old people, they have done classical. We landed with the sophisticated instrument and less human job and more instrument dependent. We tell I have done TIMS, so my precision is 0.1%. Okay, but you have purchased an instrument with a high cost. So my slogan is, with the low cost instrument, with your human brain, whether you can give the result of high precision like TIMS. That is our lifelong, my 30 years career with my collaborations. So I'll not LIBS, other things, there are techniques, but I'll be talking what is the nuclear and radioanalytical techniques, whether it is X-ray based, gamma based. But my expertise started with the neutron activation analysis and like others. Online methods at BRC also did. Recently, I'm lot of doing by accelerators because accelerators are available in India, many places. You don't have to go to really BRC or IGCA. Pixie, Piggy. Pixie is like XRF, you can do medium and high. But PIG, you can do lot of low Z elements, starting from lithium, boron isotopic, fluorine, silicon, aluminum. What are the difficulties in this thing? And if you come to hydrogen, you can do by PGNA, prompt gamma neutron activation analysis, or you can do boron. Even some people do environment studies, direct gamma spectrometry. Some people are publishing with only EDXRF or EDAX. EDAX is electron based. EDXRF is X-ray based. But this list is not complete. If something is missing, my apology. But if I come for a nuclear analytical technique, whether it's neutron, charged particle, photon, so you are basically doing a nuclear reaction. You are doing a nuclear reaction and getting a gamma ray. You are measuring gamma ray, and gamma ray intensity peak area is proportional to your concentration. If you take a sample and standard, you give a concentration. Why it is unique? Less sample, less matrix effect, more result, major minor trace. Is a great technique. But however, it cannot do surface, it doesn't do low Z element. There are issues. So, or isotopic composition. So there is another technique called PIG. There are PIXI other thing. So I will focus on NA, PGNA, PIG, and I'll let you know what can be done. You can think what we can do, how you can collaborate. If you say applications, for sure it is everywhere. Geology, biology, environment, nuclear technology, chemical science, healthcare, archaeology, forensic science, material science, what not. Almost all fields. You may be knowing lunar soil when it came, it was the neutron activation analysis gave the composition. You may be knowing one hair of Napoleon death, it was related to slow poisoning of arsenic. Whether I don't want to tell it, but the hair contains arsenic. And that one hair was analyzed by neutron activation analysis, and that hair after analysis was given back to the museum. That I have heard, I can authentically tell. What I can tell you, neutron activation after analysis of such biological sample, radioisotope decays. After some time, it is without any activity. You can return to museum. That is the advantage of the technique. But a single hair could analyze. Tell me which technique does a single hair. You can do AFM or you can do some other thing, but not analysis. And that is greatness of neutron activation analysis. Advantage before doing result, you can do hydrogen to uranium, often non-destructive with that, but you have to powder it. Made less or negative matrix neutron have, but high specificity, selectivity, many isotope, many gamma rays. When it is high sensitivity per element, then low detection limit. It can go to ppb. I cannot tell ppt, ppb. Spectral interference very, very less. I can do isotopic composition, boron 10, lithium 7. High precision accuracy I can give because unambiguous result, there is no problem. And you are applying to many fields. So many nuclear technique and NA in particular, they are very reference techniques. If you go by principle, neutron is observed target, compound nucleus, gamma ray measuring. If it is online, by 10 to the minus 12 second, called prompt gamma NA, hydrogen boron. If it is offline, radioisotope activation product, then you can do from sodium to uranium. Many elements. If you calculate about 60 to 70 elements can be done, but with a combination, not at a time. At a time, you can do 15, 20 elements easily, and that are very important elements. But we give result about 25 to 30 elements in all of our papers. Now it is bulk analysis because neutron going inside, gamma can come out. Bulk means fully sample result, total result. But if I do proton-based PG, PIXI, PIG, PIXI, then it is surface. So it is online, non-destructive, no radioactivity formation. If you are not doing pellet, sample can be returned. So these are the methods. 94, I joined BRC and I started working on NA, other thing, epithermal, this thing, ion beam also I did. Now this is external PIXI-PIG is our unique facility in India. Like NA, pneumatic carrier facility, short-lived is a unique facility in India. Some facilities are there. All are most welcome to see the facility. Please utilize the facility. We are having a good collaboration through BRNS, through UGC, through institute, through one-time visit. There are many ways to go. These are BRC facilities, but I am the, my group is the user. Here is Dhruva. In Dhruva, we are lucky to have a room that is called pneumatic carrier room, where a sample goes from here, sample comes back from after irradiation in 1 minute, and we do analysis. It's a very unique facility at Dhruva building. The new Apsara, we are going to set up our facilities. And here is the online PGNA at Dhruva. But if you see this facility, in 2010 to 12, I started working at Bandigraph. welded tandem ion accelerator. That is for low-Z elements, lithium, boron, glass, lithium ceramic, boron carbide, soil, fluorine, Madam's collaboration, we do it. Or you can take external beam, you can do a pellet. You don't have to go inside chamber. Here is the external facility, new detector I have. Beam is out, you keep a sample, small, large, and do analysis and go back. Glass, ceramic, alloys, very, very good, boron carbide. We can do, like boron carbide, I can do 30 to 40 samples a day. It's very, very important. With commercial operation, just a mylar wrapping. Here is the raw facility. This is Dhruva reactor inside. This is the thing. You might have seen. So this is the reactor. This is the wall. Well, and these are scattering chambers, neutrons. People are working here. Neutron scattering. Even prompt gam facilitators we have here. It is a Dhruva beam hall inside Dhruva reactor. Here is our pneumatic carrier facility. Sample goes here. 30 seconds to 1 minute radiation come back. Here is the capsule. We keep the sample. I can work at least 1 minute and above. All samples can be done. So 5 to 10 elements in same day we can do. This is a flux is about 10^13. This is facility I was in charge till last May, but I will be users committee member for helping people. BRC, DAE, even overall India. Here the facility of Apsara. I am showing you 10^13 flux. This is a new facility. Lot of research can be done. And calculation is either do relative method or K0, single comparator. This is my PhD. You can do a single element and do a concentration calculation. This is new idea, new concept, my PhD. We all do, as I told, method validation, that is accuracy, cross method, other method karo, precision, total uncertainty, and you do a blank measurement, do detection limit. These are 5 steps for quality assurance. If you do this, for sure your paper will be in a better journal, better impact journal. So that is the way you do. In quality control, we have to have a reference material, but presently many reference materials are not available. So particularly for ceramics, glass. So we are starting in-house reference material. Just RSC, Journal of Analytical Atomic Spectroscopy, I just got a paper for boron carbide. We do different laboratory, any laboratory is interested, we can work. So that is for this thing. So if you see the application, I will not quickly, I'll go for applications. I am now in applications. Another 10 minutes or so, I'll be finishing. 1995, we started K0, first time in India. Internal mono standard, large sample, first time in India in 2002. We have done, and we got analytical chemistry paper because we showed non-standard geometry sample without standard. Can you think of a method without any standard you can do NA? And they objected, but it's that. Then internal monostandard NA, they told no, it is already there. I defended it. Then we got the name. Internal monostandard NA means in situ, it is India method. So presently it is our like patent, but I have not filed any patent. IMNA, in situ efficiency, standardless NA is BRC, our group. Then PGNA also we started doing there. So all the applications. Based on this, I was invited in 2008 to International Scientific Committee for K0 and International Committee on Activity Analysis. First time from India, for sure. I hope Professor Gaur, Professor Rajesh will endorse. So I joined there as a committee member, presently serving as secretary for International Committee on Activity Analysis. There are 22, 25 countries are available. People are there. Big shots are there. As a secretary from 2019, and I just got elected from 2024 to 2028, second time secretary of ICA. We do validation by reference materials. We do many samples, ruby, emerald, all the things. Many samples as environmental, this thing, all this mineral ores. See, why I call CQC? Suppose a ruby or gemstone is given to you. How do you know it is synthetic or natural? A small piece was given to us. If it is natural, it contains 21 elements. If it is synthetic, it contains only 6 elements. See, if you add aluminum, because ruby is aluminum oxide, and then trace elements. Chromium is the color. So red color is because of chromium. And we found iron vanadium, if it's there, that is a natural marker. And that is not there in synthetic. So a single piece, suppose you have got thousands of rubies, 2 pieces you give us will give you whether natural or synthetic. And you don't lose anything, but you have a natural means high cost. Many times you are cheated with a synthetic or artificial because they look same. So that is our first paper in 1997. That time I was struggling to have my career. And now this gemstone and diamond and topaz, they have come for a big collaboration. We started collaboration, and in future they can have a revenue and industry collaboration. Similarly, emerald. Key elements is this thing. Emerald is nothing but beryllium aluminum silicate. Beryllium is the main. And you know how that emerald is the thing you wear it. Ladies may be knowing more. So key element is aluminum, magnesium, iron. Again, iron, vanadium. They are key element, natural. But what is that new that others have done, we are doing? I was asked by Professor Gerard Turrell, who is no more, what is that new you are doing? So that we wanted to prove. We started working non-standard geometry sample, large sample. I'll show you and how we are working. There is a method called IMNA. Just see, these samples were analyzed and we have given composition. This is a zirconium iron, zirconium 4, zirconium 4, zirconium 2. Zirconium 2 is alloy, zirconium alloy. Stainless steel. You know what is stainless steel? And all the samples were analyzed. This is high purity aluminum. Without using standard, we have given the composition, that is called mass balance. This paper clicked in analytical chemistry, journal nuclear material analysis matter. And this became a real paper for path-breaking research. This is a good contribution. Any day, this work will go to analytical chemistry book, not journal. For sure, our contributions will be highly cited in the book. This is a gamma spectrum, very quick. This is efficiency I have done. This is the stainless steel composition we have done. And I am showing how it is standardless. But here in a short time, I will not explain, but it will be standardless by mass balance. Because iron I have taken as a standard. It is an internal standard. We have not taken standard from outside. Iron is taken, but iron is not used for concentration calculation. This is beauty of this method. Then validation we have done by reference materials, D9 alloy. These are stainless steels. These are reference material from BCS. And you saw how result is good. These are gamma spectrum zircaloy and zircaloy 2, zircaloy 4. And this is a specification. And we tell that, okay, material is okay, you please use. That we can do. High purity aluminum 100% almost, 99.9. And you can give impurity. That we can do. Here you can see relative method, ICPS could not do, and INA could do. And these are the things. You can do like zircon, ilmenite, uranium ore, all the things, even uranium, thorium, very easy neutron activation you can do. How clean is spectra? Just see uranium, thorium. High purity graphite, nuclear grade graphite. It is very, very important. And this is and we could do stress element in PPB, even sub PPB we can do by this method. Because graphite carbon is not a problem. Recently, I was asked to whether a cement quality can be given. Very easy. Silicon to calcium to silicon ratio. If calcium to silicon is more than 1.5, it is a better coal. Better cement, not coal. Very sorry, it's not coal, it is a better cement. Because Portland cement is a better cement, is 1.7. And if it is less than 1, this is a cement, then it is not a good quality. Many times our constructions are there. Many buildings are falling down, all things. Our analytical, we should have our strong analytical, people should come forward. Check the cement before use. Similarly, coal, there is a big collaboration with the NTPC. We can give less coal ash, better coal. Ash is nothing but silicon, aluminum, calcium, iron, titanium. So we can easily do. So it's a good work and many PhD are doing. I have got some 4 or 5 PhD people working on this. Here comes where I have collaborated with Madam Professor Rajurkar, like arsenic, iodine, trace element bioavailability. I do not know whether Dr. Sunil Kulkarni and Dr. Preeti Bhagat come Kulkarni are present or not. But it is their work, some partly I'll be saying. Arsenic is Rakesh Sinde work with me, with Professor Ajurkar, and I'm co-guide. We did arsenic, and he did a good method of HPLC and ion exchange method, and he also did membrane method. This is the Rakesh Sinde in collaboration with Savitribai Phule University. We did arsenic speciation, and he could establish 3 ppb we can detect, and WHO limit is 10 ppb drinking water arsenic. But arsenic 3 is highly toxic, then arsenic 5, then organic arsenic is less toxic. So we established a good method, and this method is supposed to be patented, but we published in Better Journal Water Research and Hazardous Material. Iodine is very, very important. This is a very good paper, and my student almost fought with me. I told, don't worry. My last paper is always the last 4 to 5 years paper. And this is one of the best paper we published with the Professor Ajurkar, Dr. Preeti Kulkarni. Best paper. In many food, salt, reference material, it is a very unique method called epithermal NA. We could publish a very good paper. This impact factor may be now 7 to 10 food chemistry. As he published a good paper in iodine, I minus, IO3 minus. Very good paper, Talenta. She got 4 or 5 papers, all are having high impact. High impact. It's good. And salt, we proved that all iodate, no iodide. And total salt is almost iodate. That is a proof here. Just last part, another 5-6 minutes before I. It's okay, Madam Professor Ajurkar?
2 minutes.
Okay. So this is online. Online means direct sample you can analyze and give back. Archaeology, forensic, see how you can do. So directly take online spectrometry. Here is the sample detector. Detector 90 degree. You can do many things. Reference material, alloys, meteorite, cement. We participated in IEA, international project, and our results are very, very good. You know, very important is hydrogen in materials. It's very difficult to do. Direct sample taken, hydrogen has a reaction, hydrogen and gamma. It gives 2-3 keV, 2.2 MeV. You get a very good peak, and you can do it. And this I did at Budapest. A similar method we are now establishing at BRC. When I do ion beam, it is a proton. Whether if you do X-ray, it is PIXI. If you do gamma ray, it is called PIG, PIG. Particle induced gamma ray emission, not proton induced. You can do many elements by PIXI, but low Z element you cannot do. This is PIXI, like Na. So low Z element is PIG. Lithium, boron isotope composition, and all the things can be done. This is my new research. We have got almost 50 papers, many PhD. This facility BRC Potia, how a particle goes and hit the target, and we get the gamma ray. These are the facilities, BRC, Bhubaneswar, TIFR, and you can do pellet, many pellets can be done. You can do glass composition easily and fluorine estimation. You can do lithium titanate, you know, syrup, that is a fusion reactor material, lithium titanium oxygen, very difficult you can do. Lithium and battery, this work is already technology transport, but I helped in lithium estimation. It is a BRC technology transport, but lithium estimation in, this is a battery, lithium battery. Boron isotopic, I could do boron 10, boron 11, just see the reaction. Boron 11 can be done, boron 10 can be done, ratio can be given. So B10 we can give. This is analytical chemistry paper. My recent is direct sample, mylar cover. 2 minutes, we can give boron 10, sample is returned, no radioactivity, many sample throughput. So this is a greener method. This is already published in Analytical Acta 2-3 papers. And this is a commercialized. 120 was actually in maybe March. We are getting revenue. We have got very good revenue. I am very happy that it is deployed and commercially used. And it is going to NPCL DAE. And recently you will be happy to know, madam, and all people, Water, oxygen 18. Oxygen 18 is helpful for fluorine 18, PET, positive emission tomography. India is producing O18 enriched water, heavy water board. They wanted third party independent estimation. I developed a method, direct sample year detector. We are able to give oxygen 18, 1981 kb. This is a unique method, first time. It will be just published in Analytical Chemistry other paper. This is unpublished. This is the new data. Last is forensic window, EDXRA, Pixie, all this. Glass, a big project, trace element, neutron activation, do cluster, do thing. Many papers we have published, 8 papers, and there is a PhD by my student. And my student, I'm happy to announce, my student is now CFSL scientist, neutron activation analysis at Hyderabad, Vishal Sharma, for this work. This is the good work, and he's just joined in June. Many advantages, I will not tell. Conclusion, already you know that very, very important. Where you should apply material that is difficult to destroy, high accuracy required, reference material preparation, large non-standard geometry, sample that will be preserved, finished product, preserved material, archaeology, forensic, or allow these things. So very simple. Do good QA/QC, and this unique choice. So you should not have a like simple sample. Have a good proposal, good analysis. And I acknowledge. We acknowledge all my reflecting reflection. So reactor and accelerator operators, our authorities, director, chairman, our group director, my collaborators from all universities. Special thanks to Professor Rajurkar and all PhD scholars. I think I should have again collaboration with you. All ISAS, President, ISAS Committee, ISAS Pune Chapter, Organizing Committee from the RJSPM College, Vasri. Hope for sure I'll be visiting. I'll let you know. And journal team, congratulations to Professor Rajurkar, Chief Editor of ISAS Journal, President Pune Chapter. Thank you very much. With a slide, thank you with BRC. Thank you very much, Madam.
Thank you, sir. Thank you so much. We are proud to have BARC in Maharashtra. We are proud to have you for your keynote address with us, and then for that fascinating virtual tour on BARC instrumental facility. Thank you so much for being with us.
Thank you. I'll stop share now.
Yes, sir.
Thank you very much. Thank you.
Sir, we would like to present a certificate of excellence. I'm reading the certificate of excellence.
I'll record it.
Yes, sir. Please. Indian Society of Analytical Scientists, ISAS, is happy to confer this certificate of excellence upon Dr. Raghunath Acharya, Head, Isotope and Radiation Applications Division, BARC, Mumbai. He delivered a keynote address on chemical quality control of materials by neutron and proton-based nuclear analytical methods in JISS meet organized by ISS headquarters in association with IS Pune chapter, RJSPM's ACS Arts Commerce Science College, Bhosri, on Tuesday, 30th July 2024, during which he shared his vast knowledge and expertise in the field of nuclear and radiation chemistry. The lecture synergized immensely with the objectives of ISAS in promoting excellence and relevance in science and technology. This certificate of excellence is signed by ISS National President, Advisor, Journal of ISS, Dr. Raghav Saran, Chairperson, ISS Pune Chapter, Editor-in-Chief, Journal of ISS, Dr. Nilima Rajurkar, and RJSPM's SCS College Principal, Convener of this meet, Principal, Dr. KJ Kanade. I request Honorable Dr. Raghunath Acharya, sir, to kindly accept this certificate of excellence.
Yeah, thank you. I accept it with honor.
Thank you so
Thank you
much.
very much. Thank you very much. Thank you.
Thank you, sir. Friends, moving ahead, we have some presentations from our sponsors. Firstly, I would like to call upon No Chem Lab Private Limited, Dr. Varsha Chowde. Is she there with us? Oh, thank you so much. Dr. Varsha.
Good morning, everybody. Honorable dignitaries, my friends, and dear students. It is indeed a great pleasure here to be representing NOChem Laboratories. NOChem Laboratories was started in 2007 by Dr. Gore and Dr. Ashish Chaudhary with a vision to harness scientific knowledge to create cutting-edge solutions that address the challenges of our times. We are a dedicated chemistry research facility, and our expertise lies in crafting streamlined chemical synthesis pathways for both new and existing products and intermediates, of course. Right from inception to transfer of technology and also offering assistance after the technology has been transferred, we share the journey with our clients. We provide services to diverse industries that include pharmaceuticals, forensics, agro products, even fine and specialty chemicals. And this is just a few that we are naming out here. We boast of a very well-equipped synthesis and analytical lab, along with pilot plant and ETP facilities. We also collaborate with institutes like NCL and ICT Mumbai. We are right now a 25-member R&D team, and we are looking forward to expanding this team in the near future. Normally, we hire people from pure research background, both experienced and freshers. MSc in organic chemistry as well as analytical chemistry is what we look out for. The freshers we usually train for a year because, as stated by Dr. Sharan, though research is important, taking that research, converting it into technology and taking it to the industry is equally important. And the absence of chemical engineering and technology background is something that is missing in the research students. And that is what we train them for in a year before we absorb them into the lab. We really are excited about the future, especially because we see a host of opportunities out there. And we definitely look forward to working with a few of you over here. Thank you so much.
Please be seated for a minute. Thank you, Dr. Varsha. As a token of love, we would like to felicitate you. I request Dr. Nilima Rajurkar to kindly felicitate Dr. Varsha from NOChem Lab Private Limited. Thank you, Dr. Varsha, for giving this information about NOChem Laboratory. Our another sponsor is from Ormicom Private Limited, Dr. Arindam Adhikari. I request Dr. Arindam to kindly come and give us information about this Ormicom Private Limited.
Good afternoon, everyone. I am Dr. Arindam Adhikari, and I am entrepreneur since 2013, and I started with Others Innovations and contract research laboratory where we used to do contract research and product development for different companies, and also used to synthesize different types of connecting polymers and used to sell to various customers across globe. So then in 2018, we started Ormicon Private Limited, which is a innovation-driven enterprise. And our main aim is to make conductive polymers for various applications like anti-corrosion primer, EMI shielding, radar observing paints, camouflage materials. And we used to tell that this if you need two connecting polymers, you can trust us, and your destination for connecting polymer is we means Ormacon Private Limited. And next slide, please. These are some of our products. These basic products connecting different types of connecting polymers. Then one is second one is this composite, which is having around connectivity around 30 to 50 per centimeter. Then we have primers, connecting polymer based anti-corrosion primers, which is mainly replacement for chromate based primers. And then we have some other products also like Orgon C DSP, which is connecting polymer based inks, and then connecting polymer plus carbon based composite based ink also. And these are some of our selected clients. Like Boeing Research is our client, then Apple USA, Facebook, they are all our clients. And there are many German companies who are taking our material and they are doing research on batteries like redox flow batteries and different types of batteries they are working. And then electronic industries are also taking our material. And lastly, we could supply our material to Nestle Mysore. And means we have painted their Nestle Mysore coffee plant. And I also do research side by side, basic research. If anybody is interested, and if anybody is interested to have our material and do some research on connecting polymer, I am ready to help, and I'll be I'll also be happy to participate in the research. Thank you. Thank you. Yeah.
Thank you, Dr. Adhikari, for giving elaborative information about Ormacon Private Limited. As a token of love, we'd like to, ISAS Pune chapter would like to felicitate you. I request Dr. Nilima Rajurkar to kindly felicitate Dr. Arindam Adhikari. Thank you, ma'am. Thank you so much, sir. We also have two more sponsors who couldn't join us, Lab System and Biotech India Private Limited and Anand Agencies. They have sent their best wishes to our this JISS meet. Thank you. Now moving ahead, we are going to start with our scientific sessions. The scientific session, we will have introduction, then the session by the delegate, and then followed by question and answers. So I request all participants to kindly write down your questions if you have on the session any. I request Dr. Parag Adhyapak sir to kindly introduce today's first speaker, Dr. Dhakifalkar sir. Dr. Parag Adhyapak sir.
Good afternoon all. Myself, Parag Adhyapak. I'm working as a scientist in CMET Pune. First of all, I would like to thank ISAS and Rajurkar ma'am for giving me this opportunity to introduce our technical speakers. It is indeed a pleasure to introduce Dr. Dhakifalkar sir. Dr. Dhakifalkar is a distinguished microbiologist and is currently the director of Agarkar Research Institute, ARI, an autonomous institute under Department of Science and Technology, DST. He did his PhD in microbiology from Pune University in 1994. Then he joined industry for some time. After that, he joined ARI in 1995. His research career has been enriched by 2 years sabbatical at University of Virginia, where he delved into field of molecular and cellular immunology. Dr. Dhakifalkar research focuses on exploration of microbial diversity of extreme, pristine, and other environments for taxonomic novelty and industrial applications. He has demonstrated exceptional leadership by leading 27 extramural research projects and also contributed in 4 projects as a co-PI. His dedication to scientific advancement is evident through his impressive publication record. He has authored more than 100 publications in international journals with citation of around 4,000, above 4,300, with H index 34 and I-10 index of 53. Beyond research, Dr. Dhakefakar actively fosters innovation. He has successfully developed and transferred more than 11 technologies in collaboration with industrial sponsors. His commitment to intellectual property protection is reflected in his patents. He has filed around 12 Indian patents, one US patent, 2 PCTs, and a German patent. Dr. Dhakefakar is a dedicated mentor. He has guided around 20 students to complete their PhDs successfully, and his expertise in future evident as a reviewer for numerous international and scientific journals. In summary, Dr. Dhakefakar distinguished career exemplifies scientific excellence, leadership, and a drive for impactful research with real-world application. I welcome Dr. Dhakefakar, sir.
मला फक्त स्लाइड्स बुक करायला मिळाल्या बस हो हो हेलो हेलो First class. Thank you so much. So good afternoon. At the outset, I would like to thank the organizers for giving me this opportunity to present my work, especially Professor Razurkar ma'am and Professor S.F. Patil sir, who had to leave because of some emergency. But both of them have been mentors and guiding force for us, and it is always a good idea to have them here. And also, it's very nice to present in front of Professor Zinzade, one of the top 2% scientists in the world in the field of biotechnology. Always honored to talk in front of her. Also, all the esteemed guests who are present here, the dignitaries, students, and everyone. A warm good afternoon. Today, what I'm going to talk to you about is biology to energy new manufacturing frontier. So what I plan to do is I plan to present before you the energy demand of our nation. What exactly is the energy scenario, whether the energy starved nation is what we are today, and how we can do something to bridge this gap and make India energy sufficient. And that is what we want to discuss today. So basically, whenever we talk about India, it's a developing country, it's a industrialized nation. And when we talk about it, obviously there is a great deal of energy requirement. Today, we require more than 1.14 billion tons of oil, which is equivalent to gigatons of oil equivalent. And that is what our requirement was for the last year. And it has been growing at a rate of more than 6% every year. So you can imagine how fast this requirement is going up. And how do we cater to this requirement? And you will see that this requirement we cater to by using or by relying on coal, oil, biomass, etc. And in spite of that, we are still facing a lot of deficit. Whenever we talk about different sources, we will see that one of the cleanest source is nuclear energy, and it actually cater to less than 1% of our requirement. Biomass and waste, they cater to 21% requirement, petroleum 24% requirement, coal 44% requirement. That means all the sources that we are using for catering to our energy need are the ones where we are polluting environment, and that is why we have to somehow bridge this gap. If we look at overall figures, we'll see that we were able to cater to 99.7% of our energy requirement. But when we talk about it, we realize that almost 36% of our requirement was satisfied by importing energy resources from foreign countries. And that means that we are really a significantly energy starved nation. What can we do to change this particular one? When we look at it, our consumption is increasing at 5 times higher rate than whatever increase in the energy production capabilities that we have. That means our reliance on foreign industries, foreign nations for importing energy is going to go up at an alarming rate. And this actually has profound impact on the value of rupee, which is getting depreciated at every year as against to the Western currencies such as dollar or euro, and we have to do something about it, otherwise it is going to be a big problem. More importantly, we also tend to overlook the demand of our chemical industry. In chemical industries, there are a lot of industries where we need to use hydrogen, and European nations as well as Americans, they have declared a policy that 2026 onward they will not buy any chemical which is produced using gray hydrogen. That means hydrogen which is produced from the natural gas. So obviously we have to look for green hydrogen, and India is really not doing great deal as far as this particular technology is concerned. And if we are not able to cater to this particular need, that means India stands to lose more than $2 billion of business in form of supply of hydrogen based chemicals every year. And that is again alarming figure as when we consider not only the energy scenario but this inner. Now what can we do? India has come up with a plan. Government has been talking about biogas adoption policy. They are also talking about expansion of renewable energy. They are talking about energy efficiency, biomass use in the form of by supplying biomass for the energy production using coal, and they are also giving subsidy based reforms. And there are lots of such steps which have been taken by our nation, but in spite of that, we really have not been doing well. Why is what we need to understand at this particular one. Let us find out what exactly are the alternative sources of energy that are in front of us. We have nuclear energy. Fantastic, absolutely clean form of energy. But the biggest problem in our country is the politics that is associated with this. And because of politics, you have seen what has happened at Kalpakkam. We have seen at many other places. And somehow the politicians, as long as they do not understand the need and the safety associated with this and the clean nature of this energy, we will not be able to adopt that particular resource. And as a result, we have not been doing very well. Less than 1% of energy requirement is satisfied by nuclear. In fact, it is the fact that we can really do far better than this. Wind energy is another one, but again, there is a peculiar problem in our country. Wind energy, whenever we have to harvest, it has to be conducted through a very pure quality of copper wires. And the biggest problem that this industry has been facing is people are stealing these copper wires. They are stealing these cables, they are stealing this. And because of these big multinational giants who have started these ventures in India, have started pulling out of this country. Solar energy is again fantastic source which we can explore. But then for that, whatever we have, all those solar cells, they make use of nickel, cadmium, and such elements. And whom do we depend for such elements? China. And China is considered as a rogue nation when it comes to their trade policies. And obviously, it is going to create a lot of problems. Hydro energy is another area where India has been doing well, but we all are aware of the vagaries of monsoon. We also realize that our agriculture mainly depends so much on the water, and obviously not all water can be used for energy generation. So there are limitations. So that leaves us with the biodiesel, ethanol, or methanol, such liquid fuels or gaseous fuels such as methane and hydrogen. We have seen biodiesel. Ma'am is expert. Other people are also expert in this. They have been doing fantastic work, but still it has not become popular because of some of the natural limitations which are associated with it. Ethanol has been picked up on a big scale, but biomass supply is a bigger problem. And that's why the blending is also another problem. And that's why it has not yet been adopted as efficiently as it should have been. So that leaves us with methane and hydrogen, two of my most favorite gases. And I'm going to talk about that, how we have developed technologies for the production of this. Why are we so fascinated by these two gases? There are reasons for that, hydrogen and methane. But the biggest reason why we are fascinated by these two gases is because these gases can be produced using microorganisms, and they can be produced from biomass, which happens to be an abundant resource in our country, being an agricultural nation. And also it is a renewable source. So obviously every year we can have a huge quantities of biomass. More than 500 million tons of biomass or agricultural residues are produced in India, which are not used for anything else. These are in excess to the biomass which is produced and used as an animal feed or fodder. So this much of agricultural residue is available, and why can't we use it to convert it into energy? And that is something that we can think of. More than agricultural residues, we also have a lot of wood. We have dedicated energy crops such as energy cane, which is actually produced to cater the need of energy. We have algae and municipal solid waste, and these are all forms of biomass that can be used for production of this. And there are different ways in which we can extract energy from that, simply by combustion or gasification or pyrolysis of biomass. But these are technologies, some of them are polluting, some of them require a great deal of precision and consistency in the substrate supplement, and that is why they have not been so popular. So the best way is to use biomass as a feedstock for biogas production and hydrogen production. How can we use that is something that we need to think of. So whenever we talk about using this biomass, we can think about biogas, which is a very popular technology, which has been used in our country for decades together, and it has been very efficiently used, A, for heating purposes, B, for production of electricity, and C, as a vehicular fuel. Compressed biogas or CBG can be used for that purpose. So that actually is a fantastic technology. Another one is hydrogen, and hydrogen is a very clean form of energy, because when you burn hydrogen, the byproduct is water. It is also very efficient and it can be used. Unfortunately, for production of hydrogen from biomass, no techno-economically viable technology is available in our country, and that has been the bigger problem. So let's take a look at hydrogen. Why is it such a good fuel? Hydrogen, A, it is highly reactive. It is available, one of the most abundant or most common element in nature. and it has the highest energy content or uh, energy density. If you compare them with all other sources of alternative energy, you will see that hydrogen gas, it generates highest amount of energy as well as density, and as a result it has become popular. Now, how do we produce that hydrogen? It was shown by scientists many decades ago, in 1939 in fact, that algae, they are able to produce hydrogen. Can that be used as a source, was something that people started thinking about, but there were certain problems associated with that, and that's why it did not become very popular. People have used genetic engineering techniques to improve on that. Again, still it was not popular. What exactly has been seen so far is there are two major technologies that can be used. One is fermentation and another one is photolysis. When you are using fermentation, you have photo fermentation as well as dark fermentation, these two ways or pathways with which we can produce hydrogen, and you have direct biophotolysis as well as indirect biophotolysis. But if you really look at the energy yield when we are following these technologies, you realize that dark fermentation route using bacteria such as Clostridium, Citrobacter or Enterobacter, etc., the yield of hydrogen is more than 65 to 75 liters per kg of biomass. And that is fantastic when you compare it with the yield that you can get with photo fermentation or photolysis. And that is why dark fermentation has become a very popular one. And that is what we are going to look for. There are different chemical reactions which are involved. If at all some of the microbiologists or biochemists are present in the audience, they would really understand that bacteria can use glucose, and when they are using one glucose molecule, by the pathway they are going to produce two molecules of pyruvic acid, and from that two molecules of acetate will be produced. During these stages, four molecules of hydrogens are produced. If at all we have any bacterium which is carrying out this reaction at an efficiency of 80% or more, then it has all the potential of making this production economically viable. Now, there are different ways in which it can be done. If at all we have the biomass, which is a food-based biomass or edible material, then it is called as first generation. The second generation is derived from non-edible materials. Third is derived from aquatic biomass. And fourth one is derived from the engineered plants. So when we talk about that, we are most interested in the second generation biogas production or biohydrogen production. Why? We will see that. But before that, we must think about few of the aspects. Production of hydrogen using different bacteria is already reported in the literature. So if at all I develop a technology which is using some of the organisms, which is known organism, so obviously many people can copy it. It is reported in the literature and people will use it. So what exactly is going to protect my technology, my monopoly? And if at all I cannot do that, then obviously there will be so many players which will come in the market and they will outcompete me. When such scenario raises, industry is usually not interested in adopting such kind of technology. So obviously, if you have certain organism which has not been reported earlier, and if you use such organism and file a patent or protect this organism, then industry will definitely be useful. In such scenario, we try to look for some of the efficient hydrogen producing organism, especially if that organism is a novel species which has not been reported earlier. That means this will be the first report. That means we can actually file a patent on this and protect it. And this is exactly what we wanted to do. And this is the story of one such organism. The name of that organism is Clostridium biohydrogenum. So on the basis of morphological characteristics, on the basis of biochemical characteristics, on the basis of their fatty acid methyl ester FAME analysis, and as well as on the basis of DNA, the 16S RNA gene sequencing, as well as the DNA homology, we were able to unequivocally prove that this particular organism was a novel species. And since it was a novel organism, obviously we were more interested in finding out we're more interested in finding out whether the genes which were encoding hydrogenase enzyme were present in this organism. And we were able to find out there were 4 different types of enzymes or proteins that were present in this organism, which could catalyze the reaction towards production of hydrogen. And they included Fe hydrogenase, nickel Fe hydrogenase, as well as Fe hydrogenase. And there is also another enzyme, hydroxybutyrate dehydrogenase, which can reversibly carry out reaction to release the hydrogen. Now, when we look at these particular sequences and we predicted their 3D structure, on the basis of that, we were able to find out some of the interesting one. These organisms or the proteins were novel in the nature, even on the basis of their DNA structure, as well as on the basis of their predicted protein structure, we could identify they were novel. Not only that, we were also able to find out that these enzymes were thermostable enzyme on the basis of their aliphatic index as well as hydrogenopathy. So when you take that into consideration, you realize that this organism is not only novel, the enzyme that it is coding or carrying or producing are also novel. And as a result, this particular process can be protected very easily and filed a patent on it. So obviously this technology can be an intellectual property of the inventors, and then it can be adopted by the industry without any problem. Now, while doing that, it was very important for us to understand what exactly was the pathway for the production of this particular organism. And then we found out that there were three different hydrogenases were involved: Fe hydrogenase, N-nickel hydrogenase, and Fe hydrogenase. When you take that into consideration, what exactly is the importance of that? It means that this particular enzyme is the one which is a metalloenzyme. It is going to require the trace element. And whenever we carry out such kind of fermentation, at that time, we tend to overlook the main requirement for the trace elements, because this requirement may not be satisfied by the biomass that we are using. And obviously it is important. So such kind of clues we also get. We also find out that acetate is the one which is being the critical part. If at all the pathway is driven towards the butyrate one, which you can see here, then you realize that butyrate production can be little tricky, because butyrate is going to consume hydrogen when acetate is not going to do that. And as a result, from glucose to hydrogen, we will get 4 moles of hydrogen. If we go glucose to butyrate, we'll get only 2 moles of hydrogen. So somehow we have to block this. And through butyrate, if at all it goes further down, or through acetate, if at all we are allowing it to go further down towards the production of lactic acid, succinic acid, or ethanol, or such kind of production, then again it will start consuming hydrogen. So that means we have to block somewhere at this particular point. And that was the take home messages. So when we actually did this kind of analysis, we realized that we just wanted to confirm that these all genes were present, but they were getting expressed and they were playing an active role. And for that purpose, what we did was we checked out when the particular culture is producing hydrogen at its highest capacity, what type of genes are getting overexpressed. And we found out that Fe hydrogenase as well as Fe hydrogenase, their production or expression was significantly upregulated. And also the hydroxybutyrate dehydrogenase was getting significantly upregulated, while lactate and acetaldehyde dehydrogenases were the ones which are getting downregulated, meaning that under the set of conditions that we had optimized at that particular point, the acetate was becoming the end point. Butyrate was at exactly acetate to butyrate ratio was more than 2, and it was not going further towards the production of lactic acid or towards the production of acetone or ethanol production. And that is something that was actually making this particular process very sturdy, and it was being run at a very high efficiency. So when we take all these things into consideration, that gave us idea about trace element requirement. It gave us idea about use of inhibitors that could inhibit the enzymes that could further catalyze the metabolism of acetate into production of solvents. And based on that, we optimized some of the conditions, as you can see in this particular table. So these were the conditions which were significantly supporting the hydrogen production. Now, when we take this into consideration, we have solved one problem. That problem is of production of hydrogen using an efficient culture, using the culture which is, can you press the next button, please? Yeah. So actually, I will just continue with that by the time we get the slides back. So the point was very simple, that we have a novel culture, and this particular culture was found to be very efficient. We had found a ways of making sure that the entire metabolism is driven towards the production of hydrogen. But what exactly is the substrate? Substrate we plan to use is a biomass. This biomass is a lignocellulosic biomass. Lignocellulosic biomass is a very interesting biomass or substrate. The reason I say that is because there are the lignocellulosic bonds which are present. So lignin is covering the cellulose as well as hemicellulose. Next. Next, please. You can just. Yeah. So the important part is this: if this biomass has to be degraded, that means we need somehow a culture that will produce the lignocellulosic enzymes in such a way that the biomass can be efficiently degraded without thermochemical pretreatment. If at all such culture is not available, that means we have to expose biomass to 4% of alkali at 180 degrees Celsius. That means the entire process is going to become a techno-economically non-viable. It is going to be energy intensive. It is going to be polluting, laborious. So there are several drawbacks, and most importantly, it destroys the economics of the process. Now, for that particular purpose, one of the ways to overcome this is simply by using a interesting culture. And that group of culture that we have been working very extensively on is anaerobic fungi. These anaerobic fungi were isolated from the remains of the ruminating animals, and these ruminating animals actually have a very interesting group of fungi which produce a structure which is called as cellulosome. And this cellulosome is a very interesting molecule because it has a complex of enzymes. These enzymes include cellulases, hemicellulases, and ligninolytic enzymes such as coumaryl esterase, ferroyl esterases, endo and exoglucanases, glucosidase, as well as xylonases. And all these enzymes, they are docked onto the surface of the anaerobic fungus. They are not released out, and as a result they are able to degrade this lignocellulosic biomass very efficiently. And as a result, you can very easily see that the organism is able to degrade it without any thermochemical pretreatment. Now, what is the implications of that? There are some figures where we have shown the structure and how exactly it acts on that, but it's okay. Don't worry about it now. So what we did was we optimized the conditions using these anaerobic fungal cultures, and we optimized them in such a way that anaerobic fungal culture was able to saccharify the biomass and produce sugars. And these sugars were then effectively used by the Clostridium culture, and this Clostridium culture was able to convert those sugars into hydrogen. Now, when we were doing that, there were a few interesting things that we observed. We got the yield A on one hand of 80 liters of hydrogen per kg of biomass. That itself is one of the highest ever reported. The second highest is only 16 ml, 16 liters. So as compared to that, you will see that there was more than 5 times incremental yield that we were getting with this. So that was fantastic about this particular culture. We also had the anaerobic fungal culture, which was able to hydrolyze or sacharify the biomass, produce sugars for this particular culture. When we combine them together in a biogas digester, we were able to get hydrogen yield, but the volatile solids that were getting degraded, it was not even 60% of the volatile solids. That means there was huge amount of solids which were available to be converted by microorganisms. So what we did was we developed a process where in the first digester we carried out the hydrogen production. In the second digester we carried out the methane production. That methane can then be converted by steam reformation into hydrogen. So now from 1 kg, we were getting 80 liters of hydrogen, 200 liters of methane. But by steam reformation, from those 200 liters of methane, we were getting again 800 liters of hydrogen. So overall, we were getting 880 liters of hydrogen. Now, what is the beauty of this? When you take the entire process economics into consideration, then you realize that the hydrogen production cost, which otherwise would have been 660 rupees per kg of hydrogen, came down to less than 200 rupees of hydrogen 200 rupees per kg hydrogen. Now, what is the significance of this particular observation? Whenever hydrogen is to be used as a fuel, at that time, you have the cars which are running for multiple kilometers. You have two choices. You can use hydrogen in the form of ICE to run an ICE engine, or you can use it for a vehicle where you have a fuel cell. In either cases, both the technologies are standardized technologies where the hydrogen per kg, you can get up to almost 50 to 80 kilometers of car running. So that means if at all I'm getting 50 to 80 kilometers for 200 rupees, then it is not bad. We can request government to give some subsidy, or when we can go for higher production, it would really bring down the cost further. If you compare that with the biogas, this becomes even more economical. It not only economical, but it also becomes more environment friendly. And that is another beauty of this. So when we took all this into consideration, we realized that this had to be demonstrated on an industrial scale with the large scale plants. And I had some beautiful pictures in those slides where we had done this at other industry site, where we constructed the pilot plants of 10,000 liter capacity, and 3 in the sequence where we have done the mixing of the biomass, then saccharification using the hydrogen producing bacteria, production of hydrogen followed by production of methane, and then the steam reformation process. So by doing all that, we have been able to crack this particular one. Now, this has also not only the second part is true, but there is also additional application that we have opened up now. We can have this decentralized plant all over the nation because agricultural residue is available everywhere. The biggest problem with all these fuels such as hydrogen, etc., is the cost associated with the transportation. And now we have been able to eliminate that cost because we will have the decentralized biogas digester or hydrogen reactor. So the transportation cost is again eliminated. And most importantly, this hydrogen can also be used for the synthesis of chemicals because this hydrogen is a green hydrogen. And if at all we use this green hydrogen, then the industry's problem that they would be facing with gray hydrogen will be absolutely eliminated. So when you take all this into consideration, we realize that this particular technology is a beautiful technology. It has already been transferred to KPIT Technologies Limited for hydrogen. For methane, it has been transferred to GPS. And thirdly, it has also been adopted by Thermax. And with these three industries, we hope to see more than 200 plants of hydrogen or biogas production in a very short period of time. And I believe that whatever call our Honorable Prime Minister has given to make India an energy sufficient nation and make it independent of any of the imports by 250, this is a very small but significant contribution from Agarkar Research Institute towards that effect. Again, I would like to thank Professor Razurkar ma'am. You were not there, but thank you so much for inviting us and giving us opportunity. And I wish I could stay for the whole day, but I had to go to other place also, and that's why I'll be leaving. If at all there are any questions, I would be very happy to take them. And otherwise, thank you so much. I appreciate it. Yeah, please.
How much cost would be in the entire process? Hello, sir.
Yeah.
My question is how much cost will be involved in all this process? Also, whether once it will be at the public places, so whether the government will be providing subsidy or any such.
Yeah, so there are multiple answers to this particular question. There is one plant which has been established at Barabanki in Uttar Pradesh by GPS Renewable, where our technology has been implemented. The plant is for Reliance, and the plant is for 100 tons of biomass per day capacity. So from that biomass, we are producing around 7 to 11 tons of hydrogen per day. The economics of that plants are as follows. Initially, this plant was operated on thermochemical pretreatment and then followed by biomethanation. Then they adopted our technology. So with thermochemical pretreatment for 100 tons per day capacity, the annual expenditure of that industry for 330 days per year operation was 46 crore rupees. I'm talking only about the consumables. The biogas yield that they were getting was to the tune of roughly 5 tons. So the cost that they were getting for that was around 42 to 43 crores. So actually they were in a way little bit of loss. If you consider the cost of the capital expenditure, then they were in great deal of. When they adopted our technology, the pre-treatment cost and operating cost came down from 46 crores to 3.8 crores. Biogas yield was almost double. Now you can imagine the difference and the impact that it has been making. That is with respect to only biomethanation. They did not even bother taking hydrogen into consideration. Now, in addition to that, there is a great deal of cost for the organic manure. Whatever solids are there, those solids are separated and sold as organic manure. The liquid that is generated, it is also used for production of algae and diatoms, which are again reused for the production of oil. So there is also another one which is there. And after recycling, whatever water is released, we are using it for the production of methanotropes. From that, again, we are using methane mitigating bioinoculant. So those are additional cost. So I hope that answers your question. Yes, ma'am.
That was indeed a very interesting talk.
Yes, thank you so much.
I have a couple of questions.
Yes, please.
So my first question is, whenever, look, what is the amount of inoculum that you are adding? How frequently you have to change it? And second is, when you change it, what about the previous one? And the last question is, how pure the hydrogen is? Is there any other gas that is co-produced and how you separate it?
Yeah. Very important questions, all of them. First and foremost, the hydrogen purity is 80%, 80 to 85% that we are getting. Remaining is CO2. There is no other gas which is present in detectable quantities. We purify that using membrane filtration, or we sometimes use the pressure swing adsorption method, which is more economical, but industries tend to prefer the membrane filtration technology because it is more efficient. The purity that you get with both the methods is 95 to 99.8%. So that is where they are used. As far as inoculum is concerned, inoculum you actually require to the tune of 10% of the total reactor volume. Now, if at all we consider the loading rate of solids at only 5% in this particular one, and if 100 tons per day capacity is there, that means for 10 days, 20 days HRT, I will be adding 2000 tons. And then 5 times of that, that means 10,000 meter cube is the reactor volume. Now for that, if at all I have to get this particular inoculum, then it is going to be practically impossible. We do not have any kind of fermenters which can do that. So what we do is we get the cattle dung as an inoculum. In cattle dung, there are 3 chemicals which I'm not going to tell you, which we add, because of which this particular culture gets augmented. When it gets augmented, we start supplementing them with the rice straw and we slowly go on feeding it. So we take total of 25 days to fill the entire reactor. During this process, we are getting the desired inoculum setup. At the same time, we also have another fermenter which is set up. This fermenter is only rice straw based fermenter. It has rice straw. There is no nitrogen supplement. There are trace element supplement, and we cultivate the anaerobic fungus in it. And whatever is our daily requirement of that 1% volume by volume, we are adding anaerobic fungus, which comes to 2000 liters of anaerobic fungus every day. Anaerobic fungus takes 3 days to grow. So the reactor volume which we have is 10,000 liter total volume, 6,000 liter working volume. The headspace is biogas, which we are maintaining to maintain the inert one. Most of the times, once that reactor is charged completely, we don't have to give the bio inoculation again. But industries have a very bad habit. Many times they are not able to organize or arrange the biomass in the quantities that they are requiring. So as a result, what they tend to do is instead of biomass, you add something like press mud or molasses. If press mud is added, then this particular reactor gets acidified, the entire inoculum gets killed or washed out. So in such cases, we have to again readjust the pH. We have to recharge them. Recharging is done at again 10% of the volume that we are putting in, but it takes almost 25 to 30 days for the reactor to recover. During that time, the entire operation is losses again. So if the microbiologist is operating the reactor, we do not face the problem. If there is no biomass, he will not put the biomass, he will stop the production, but the culture will remain intact. If the chemist is operating it, I'm sorry. Then many times they just add whatever is available, because for them, if the culture is not going to use such a simplified sugar, then I don't need this culture. That kind of attitude they show, which where we are helpless. We have faced this problem in the field, and that's why I've shared it with you. But
They trained properly, then they would not do this.
no, actually, there are economic compulsions. They have the target that so many tons of biogas is to be produced every day, or hydrogen is to be produced every day. And unless you produce such huge quantities, the management is not very happy. The management will not accept any excuses, so they will just dump anything and start producing. So that is a
One
problem.
last question.
Yes, please.
This is with the wild type culture.
Uh-huh.
Have you ever thought of mutating those?
No,
to
the
make this thing?
genetically engineered cultures, which we actually develop in the laboratory for PhD students to beautify their thesis, but we are not using them in the field because in India, you cannot use genetically modified culture in the field. So that's
Okay,
the
thank
reason.
you.
Yes.
What type of biomass is used?
Rice straw is the main one that we are using. Energy cane is our second most favorite. Maize is the third most favorite. And apart from that, any straw category of crop can be used. Yes, sir. Thank you so much, sir. Yes, sir. Sir, there are three trace elements which we use. Molybdenum, everybody knows, so I will share with you. Nickel, you know, obviously from this. Third element is the tricky part. Please don't ask me, but we use them. Ferrous, sir, ferrous. Yeah. FeSO4. Yes, thank you so much.
Thank you so much, sir, for giving that elaborative information. And we are chemists, we are organic chemists, so we must know about these things. So thank you for that journey of biology to journey. I request Honorable Dr. Rajurkar ma'am to kindly hand over the Certificate of Excellence and felicitate Dr. Prashant Dhafekhalkar sir. I request all participants to kindly give big hand to Honorable Dr. Prashant Dhakefalkar getting felicitated with the hands of Dr. Nilima Rajurkar. Thank you so much, sir. Thank you. Our next, without wasting our time, let us go ahead. And our next session will be conducted by Honorable Dr. Smita Zinzade, Director, School of Life Sciences, SPPU Pune. Before she begins, we would like to introduce her. I request Dr. Geeta Sharma to kindly introduce Dr. Smita Zinzade, ma'am. Geeta.
Thank you, ma'am.
Good afternoon. I'm Geeta Sharma from the Department of Chemistry, Savitribai Phule Pune University. It's an honor for me to introduce the next speaker for this session, Professor Smita Zinzade, Madam, the Director of School of Life Sciences, Savitribai Phule Pune University. Professor Smita Zinzade, Madam, is an alumnus of the Savitribai Phule Pune University. She has completed her MSc and PhD in microbiology from the University of Pune. Since 1998, she is working at SPPU in various capacities, such as research associate, lecturer, associate professor, and professor at the Institute of Bioinformatics and Biotechnology at Savitribai Phule Pune University. She has shouldered many administrative responsibilities at SPPU as the head of Department of Microbiology, the director of IBB, head of Department of Biotechnology, and currently she is the director at the School of Life Sciences since December 2020. Madam is a recipient of the Young Scientist Award from DST, and she has also received travel grant from INSA. She's a member of Board of Studies in Microbiology at SPPU. Zinzade Madam has garnered funds to the tune of 2.5 crores from various funding agencies such as DST, DBT, CSIR, UGC, Naval Research Board, and industries. She has mentored 11 students for their PhD degree, and she has mentored 6 postdoctoral students also. Madam has to her credit 99 publications in journals of national and international repute, 15 review articles, 12 book chapters, and 5 patents. Her name was also featured in the top 22% scientists in the world consecutively in 2020 and 2021 as per the Stanford ratings. I welcome you, ma'am, to the JSIS meet. And today, madam will be talking to us on the catabolic versatility of microorganisms. Thank you, ma'am.
Yeah. Thank you so much. Yeah. A very good afternoon. I must thank the organizers for giving me this opportunity to come and present a little bit of my work for the students, mainly for the student population that I see here. And of course, all of us can also understand. Dr. Dhake Farkar has dealt with an important parameter that is relevant for the current day, that is energy. And the other thing that is relevant with respect to environment are the different types of pollutants that are going to be there. So I will try to focus on some of these problem creating compounds that are there and try to find out how microbiology. Dr. Dhake Farkar is also my senior, and we were in the same department, and so we know each other for a long time, and he is also a microbiologist. I also happen to be a trained microbiologist, and you will appreciate at the end of the talk that there are a large number of microorganisms that are available. They have a lot of catabolic potential. Catabolism is breakdown. Okay, anabolism is building up of matter. So I'm going to focus on the catabolic potential of microorganisms. I will focus. There are a large number of You must have seen from the previous presentation that the microbial diversity is immense. But I will try to restrict to make it more focused and deliverable in half an hour. I thought I will restrict to just one organism. From this, you would understand it's just the tip of the iceberg, and at the end of the exercise, their biodiversity is so immense that if I'm just telling you about one organism, the potential is immense, is what I'm sure you will all appreciate. So I've titled this as Understanding the Catabolic Versatility of Microorganisms. As I told you, I'm going to tell you something about Gordonia. Okay. Okay. Put again. Next one. So what is Gordonia? Thank you. Dr. Dhake Fargar was just telling us that there are a large number of microorganisms. This one happens to be another one that is there. If you were to, for the common person, for the students who are of non-biology background, maybe we have heard of mycobacterium that causes tuberculosis. Everybody can relate to tuberculosis. Everybody knows there's a disease called as tuberculosis. It's just caused by an organism called as mycobacterium tuberculosis. Another example I have given is rhodococcus. Rhodo is red, coccus is a spherical organism. Okay, so these are relatives of Gordonia. Mostly they are beneficial. Some of them can be opportunistic pathogens. So we have to be a little worried about when we are working with these kind of organisms. So this is the genetic, you know what, genomic, what would you say, phylogenetic properties of this particular organism. This one is, all right, that's a plate showing you a culture of Gordonia. I don't know if you can see it, something orange colored. This organism has a pigment, which I'm going to tell you all something about a little later. And this is how it looks like under the microscope at different magnifications. And it has a large number of physiological traits and biochemical properties that are significant in the remediation. That's what I'm telling you. I'm going to try to address some of the problems that are associated with different pollutants and try to address them by using this organism. What you have is physiological, it is able to tolerate temperature, pH, halotolerance it has. It also produces a large number of enzymes. It produces surfactants and pigments. So what I'm going to do is, since I'm telling you something about the catabolic potential, I will talk about some different types of pollutants that are there and how this organism is able to degrade them. So, I don't know if I'm, all right. What I have done is picked up the contents of a review that was recently published, not recently, 2 years back, 3 years back, on the topic. And there we did an extensive literature survey and we found out that this organism really, today I'm able to stand here and tell you that this organism is very important for treating pollutants is because of the extensive literature survey that we were able to carry out. And we find out that this is the title of that. It says harnessing the catabolic versatility of Gordonia species for detoxifying pollutants. So what I'm going to go through with this first part, I'll go through quickly, and then I'll focus more on the work that has been carried out in our laboratory. The first part will be a little bit of literature survey, and then for you all to just appreciate that it has a lot of catabolic diversity. So it can degrade. This is just a summary slide telling you that it can degrade hydrocarbons, then it's RDX, the explosive, then cholesterol, pyridine, fuel oxygenates, the list just goes on, okay? You can also get some value-added products from conversions of these particular products. And they're also significant in the treatment of wastewaters that are rich in steroids and lignins, as I'm going to tell you. They are a large number of reports wherein, this Gordonia species are known to bring about degradation of, I suppose, all these kind of hydrocarbons that are there. So it is a major degrader of hydrocarbons that we understand out here. These are for the sake of, I'm sure all the chemists will know that, but for the biologists, maybe hydrocarbons, as we know from the name, that there are hydrogen carbon containing compounds and they are sparingly soluble. The problem with biology is everything should be water soluble for the organism to be utilized. The moment you have a solubility issue, we run into problems, okay? So hydrocarbons are sparingly soluble and there are two ways by which they take up, either by attachment to large droplets or they produce these surfactant active compounds. Okay, and this organism is capable of producing surface active compounds, and these surface active compounds, a large number of applications that are there. That's a beautiful picture that we have taken of Gordonia amicalis that is growing at the expense of an hexadecane. This is the, what would you say, a phase contrast image of this. This is stained with a dye called as Nile red. Nile red is specific for oily substrate, so it will give you a red coloration with that. This is a dye that is specific for DNA, so any organism that is there would be stained blue dappy. And when I do a superimposition, you can see a red background wherever there is oil. And because of the blue and the red overlap, you get a purple image. That is where this means that the purple dots that are there are microorganisms attached to the droplet of the oil that is there. So when we did this literature survey, we understand that even hydrocarbons such as propane, that's the smallest one, and just 3 carbons that is there. There is an intricate possibility of a pathway that is present in this organism that can bring about the conversion of propane into something like acetic acid or methanol that is readily biodegradable. So the challenge is with this kind of a compound, which is actually quite inert from the biological point of view because it's just carbon and hydrogen. So this organism has the ability to bring about a large number of, changes to it. And the take home is that you get acetic acid, which is easily utilizable by microorganisms. Then this has also the ability to degrade. Can we minimize that that panel, ते वरची panel minimize करतात? ती जी काळी पट्टी येते ना, काय काय आपल्या इन्फॉर्मेशन बरं, all right. ते साईडला घेऊ शकतो. Anyway, this is for the long chain hydrocarbons that we are talking about. A long chain is, say, for example, you have here. All right. This is the long chain one that we are talking about. First picture I showed you was for propane, just 3 carbon. These are long chain ones. Again, they have a very intricate, this is a beautiful figure that my student drew for the review. It is her imagination that she put in, and that the membrane, and you have the associated complexes of the enzymes that are there, and the pathway that is followed. Essentially from this inert, that is CH3 containing group, you have something that is a COH group. The moment you have a COH group, it becomes a fatty acid and it becomes easily biodegradable. So that's the most important thing this organism is able to do: add a hydroxyl group into an inert compound, make it vulnerable to further degradation. तुम्ही केडा पुढे? All right. Not only aliphatic hydrocarbons, it also has the ability to degrade a large number of aromatic compounds that you see from this table that we made with respect to this organism. These are large number of anthracene, pyrene, phenanthrene, naphthalene are all degraded. The next thing we found out was this organism has the ability to desulfurize some compounds. Very often crude oil has a large number of sulfur containing compounds. So there is a pathway that exists in this organism by which it can bring about desulfurization. There is a sulfur group here. At the end of the exercise, it is devoid of sulfur. Therefore, it has the ability to desulfurize organic compounds. That was an interesting observation that was made by us when we did this literature survey. And of course, out here are details wherein which organism does that. And in literature, which is the report where you are able to see such kind of desulfurization. Then all of us also know that plastics are a major problem, and phthalates are used for making these plastics. This organism has the ability to degrade a large number of phthalates that are there. We actually made a comparison. So this is the structure of the phthalate. Phthalic acid is this. So this is butyl benzyl phthalate. This is the phthalate. This is the butyl group, and this is the butyl group, and this is the benzyl group. So you have such kind of combinations that are there. The left-hand side will show you the different types of phthalates that were there, and how this particular organism, depending upon the type of phthalate and depending upon the organism strain, will give you different products that are there. So essentially, we're trying to get them into, so you begin with something like this, that is a pollutant, into something that goes into TCA cycle and helps in the development of biomass. So that is something that we observe. So this is the summary of the pathways that are present in this particular organism. Then another interesting, you see rubber tires lying all over the place. Okay, so we are worried about what's going to happen to what's going to be the fate of these tires. So this organism has the ability to also bring about degradation of rubber. There are 2 ways by which bacteria can bring about degradation of rubber. One is, for example, they will form a clearance zone. I don't know if you can see, there is a clearance zone around. This is a bacterial growth that you see on a plate, latex overlay agar plate, and there's a clearance zone, or this is a piece of rubber, say, and you see some white colored organisms sticking onto that. So that's showing you that the organism has the ability to either form a clearance zone, or, by surface, they'll start eating up the rubber pieces that are there. So it becomes very, very important, because we have a lot of problems associated with rubber that after use, the tires are normally discarded, and this organism holds promise in giving you some kind of a solace for treatment of such kind of property. So this is a pathway by which the organism has the ability to degrade rubber. Essentially, rubber is this kind of a structure, and it eventually it goes into beta oxidation, means it is available for growing the biomass of that particular. nitrile. So these are representative nitriles that this organism can bring about transformation. You also have RDX, as I told you, that's the chemical structure of RDX. It is able to bring about transformation from one kind into other. And sometimes you can have two cultures. This along with another culture, we get complete degradation of RDX. So that was another observation that was made. You have pyridine and other related compounds that are also subject to transformation by using this particular organism. And then you have fuel oxygenates of different types that can be, transformed by the different stages. You can see that there are, now this G. terri means this Gordonia terri is one particular organism. You also have Amicalis, another species of that. So every organism will have a diversity in the enzymes and the metabolic pathways that are going to be there to bring about degradation of these compounds. So lignin and organic compound containing waste were also degraded by this. Now this is a table that shows you the patents that were, whenever I write a review, I want my students to really let me know if this organism is beneficial. There has to be a technology. Okay, so we look out for a patent search, and for this particular organism, we were able to make a table of the patents that are there, which means that it holds a lot of potential in getting a technology developed. Okay, so this is a summary that we were able to get. For, if you see this middle column, it's all Gordonia. Okay, and it's on the left hand side, what are the patents for? So it has a tremendous potential for giving you technologies, is what we understood from here. The next thing we worry about is about metals. A large number of metals are prevalent in the environment, and they also cause a lot of problems. And we did some kind of, this was our own work that we put out here. And this particular strain of Gardenia amicalis, we were able to show that it can interact with, of course, gold and silver nanoparticles that were able to be formed out here. If you see, this is the cell of Gordonia. This is also the Gordonia. I don't know if you can see some white dots in there. They are the nanoparticles associated with the cells. So are these. These are gold ones. These are silver ones. And if you see them under the microscope, they will appear in this fashion. Okay, so the take home from what this review, this just to highlight that the organism holds a tremendous potential in addressing, I told you, so many different types of chemically unrelated structures that this particular organism has the ability to degrade, detoxify, transform into more value-added products. So on the basis of this, we concluded that this particular organism has the ability to degrade all these compounds that I have listed out here. This is a summary figure that we have presented in the review, and we really understand that. I'm sorry for this this change. The normal presentation would have it all in place. There is some formatting issue, as a result of which some text spills over. So that was what summary of, just telling you what others have done with respect to this organism. We wrote up this review because one particular student was working on this organism, and for the first chapter of the thesis, I normally encourage writing up a review so that your first chapter is ready by the time you are about to submit your thesis. So that is the reason why we got that very good review in Biotechnology Advances, which was a very high impact factor. And now what I would like to do for the sake of the students is something regarding the contributions from our own lab with respect to Gordonia. All right. This is something that I've already told you. This is Harshada. She happens to be Dr. Kulkarni's student. She worked with me for quite some time. Since I had the expertise in hydrocarbon degradation and all that, we had the joint collaborative project, and she's been extremely productive. And what I'm presenting today is a part of her work that is there. It's for anybody who pursues your PhD. You must remember that you should be like Harshada. Okay, that is the kind of thing that we should have good. See, she has a review in a journal called as Biotechnology Advances. She has now critical reviews in microbiology, another classical journal for microbiology. I'm a trained microbiologist. I love to have papers that are in classical microbiology journals also. And of course, we wrote up a book chapter also. Now, what she did was we tried to degrade two. Hexadecane is very commonly degraded. So we use that as a standard compound for comparative purposes. But the novelty of the work that she presented was on squalene degradation. As we had done, I told you, we have done extensive literature survey on the topic, and we understood that there is this gap in literature. I showed you so many compounds that could be biotransformed, but one for squalene degradation was the gap that we identified, and she took up this work. This was, see, everything she did, her thesis was completely published in the form of one paper or the other. Okay, right from the introduction to the last part. That is the kind of thing that, all PhD, anybody who's wanting to do a PhD should aim for such kind of a thing. Okay, so this is international biodegradation and biodegradation decent impact factor. So what was it? Biodegradation of squalene and an hexadecane by Gordonio amicalix with what you get, not only degradation, but you get a value-added product in the form of a biosurfactant, and we get carotenoids from that. So we worked out the ways by which the organism is able to grow, bring about self-extension reduction at the expense of hexadecane, at the expense of squalene. What is the residual content? As the organism keeps on growing, the content of the hydrocarbon that is provided goes on decreasing and biomass goes on increasing. So this is indication of the biomass increasing. This is indication of the substrate being degraded. We also worked out the pathway. Since it was the first time that we were working on squalene, we tried to do some GCMS analysis. What you do is expose the organism to that particular compound, pick up samples from time to time and find out what are the intermediates that are there. On the basis of that, we were able to identify the pathway by which this organism is able to degrade this. So this, I don't know if you can see, but this is the squalene that is there. It is branched hydrocarbon. So it becomes, if it is stretched, easy to degrade, but branch-in ones are very difficult to degrade. And this organism, because it has the ability to degrade things like isoprene, which is present in rubber, we thought that it will be able to. There is a logic in doing everything that is important for the students to understand. Okay, so we worked out the pathway, and we said that we begin with this kind of complex. Well, I'm very satisfied when it goes to carbon dioxide. That means that forget about all the other pathway, but if it goes to carbon dioxide, there's complete degradation of that compound that we are talking about. We did some beautiful microscopic analysis. SPPU has a very nice facility for confocal and things like that. And all these facilities, all the work that is being presented here is exclusively to the work using all the facilities that are there in SPPU. I must thank the SPPU for providing us with such wonderful infrastructure. And then we did a lot of characterization with respect to how does it attach. I don't know if you can see, but out here you will see larger droplets and the droplet size decreases, which means that they are utilizing the hydrocarbon of interest that is there. Then we did a lot of fatty acid profiling to find out whether there is a change. And this one is related to production of a biosyn. As I told you, we efficiently were able to show that squalene is degraded. But not only degradation, but if you have the ability to show a value-added product being formed, then gives you more advantage. So we got two value-added products of this whole thing. We got a biosurfactant, and the second one was carotenoid. Biosurfactants are surface active agents that will, how can I tell you? If you take water and oil, there'll be two phases. Oil will be on top, water will be below. But the moment you add a little bit of soap into that, and you mix it up, what happens? You have an emulsion. For the sake of the students is what I'm trying to tell you. Think of some biologically produced surfactant, something that will change the interfacial tension, that will change the surface tension, is what we were able to show, that this organism produced the surfactant and it also produced carotenoid. So these were the value-added products. We optimized the parameters for production of these two value-added products. So that is just, I'll maybe just quickly tell you that this was the abstract and the conclusion part that we say. The take home from this is the organism was able to efficiently degrade squalene as well as hexadecane and give you two value-added products in the form of biosurfactant and in the form of a pigment called as carotenoid. These two, biosurfactant and carotenoids, we are going to use later on for synthesizing nanoparticles also. So that is the interrelatedness between these two. We went ahead and talked about, all of us are worried about hydrocarbons, diesel. You go to a petrol pump, you'll see so much of diesel just spilled all over the place. So we are adding a lot of these pollutants in there. And this organism showed great potential in degrading this particular diesel. And this was also in a very nice journal. It is called as Environmental Pollution from Elsevier, with a nice impact factor of 7.6. And we were able to demonstrate that diesel was very efficiently degraded. We optimized the parameters. We changed the diesel concentration, nitrogen sources, nitrogen. Once we identified ammonium sulfate, we varied the ammonium sulfate. We optimized the condition for pH, temperature, agitation, and we were able to get decent degradation of diesel by this particular organism. This is just like your previous picture that I showed you. There is growth, there is surface tension and reduction in diesel content. Since this is an analytical chemistry kind of a thing, maybe for the students' benefit, we do use a lot of analytical techniques for finding out the degradation potential, as evident from this particular gas chromatography profile that is there. This is before degradation, wherein you see a large number of peaks that are there. And if you expose these to the organism that I'm talking about, it utilizes that, builds the biomass. And if you extract out the diesel from here, the content, can you see, they're minimized. So all of this that was present initially has now been utilized by the organism, and your environment has been cleared of the pollutants that are going to be there. These are beautiful pictures of the organism in the presence of, say, this is Luria batani broth, where you see the rough surface, but in the presence of diesel, you see a smooth surface. That is because they're producing that surface active agent. So it becomes covered with that surface active agent, and it appears as a smooth structure. This again showed you that this is diesel stained by Nile red, and this is after 24 and 48 hours that are there. You can see that the size of the droplets keep on increasing. This is DAPI showing that the organism is there, and this is a superimposition showing that the organism number is increasing and diesel content is decreasing. We also try to see the toxicity reduction after treatment of the diesel oil. We found out the residual content that was there. We demonstrated that we used the onion root tip, allium cepa root tip experimentation to demonstrate that the toxicity associated with treated diesel was much lesser than, with untreated controls that we were doing. A large number of parameters. We summarize all the parameters with abnormalities for the treated and the non-treated, and showed that the take home from this was that it has the ability to utilize diesel as a sole source of carbon. Sole source of carbon means you just provide the organism with diesel, it will utilize that up and grow. That is the, normally glucose would be used for growing most of the microorganism, but you have something which is a waste, and if the organism is able to degrade that, that is very, very desirable as such, okay? Then it produces this surface active compound, which brings about emulsification. I showed you some of the morphological features change and the lower toxicity of the diesel as a result of the degradation. All right, this is the next thing I told you. It produces two value-added products. One is a surfactant, and the second is a carotenoid pigment. So both of these have potential for synthesizing nanoparticles. Okay, let's see how we did some very interesting work on this. And this is a nice paper that we got in, I think this is in process biochemistry, which is an impact factor of 3.7. Carotenoid stabilized gold and silver nanoparticles derived from this particular one strain is what we are talking about. So you get nanoparticles of gold, and you also got of silver. These are typically the UV visible spectra. These are the XID profile showing you that what we are actually getting are nanoparticles. Here you have the cell I must have shown in this image earlier. All those white dots that you see are the nanoparticles as evident from the EDS profile. They indeed tell you there is a signal for gold, there is a signal for silver. Then we wanted to know what is there in the organism that is mediating. I told you it is an orange colored culture rich in carotenoid. So we isolated the carotenoids from this. A large number of carotenoids are produced by this particular organism. We isolated them and characterized, I think, 2 of them, and find out, again, your analytical techniques come into picture when you're trying to identify what is the structure of the carotenoid. And once we identified, we got 2 novel carotenoids from this particular organism and presented them in this paper. And the isolated carotenoids were also able to synthesize nanoparticles. You take the carotenoid and you expose it to the silver chloride or orium chloride, and we were able to get kind of monodispersed nanoparticles. And these are, you can see, more or less of the same size. So rather than having a varied size of nanoparticles, because we got the purified compound, we got better size nanoparticles as such. Now we have to explain the logic, what must be happening. And therefore we hypothesize that this tertiary hydroxyl groups that are there, when you under alkaline conditions, you have either orium chloride or silver nitrate, you have them converted from the ionic form to the elemental form. And these are the two carotenoids that we were talking about. Your OH groups get eliminated and the carotenoids get oxidized. All of us know that carotenoids are important antioxidant agents. We're all the time asked to eat beetroots, carrots, and so many other colored fruits. That is because they are rich in these carotenoids. And because these carotenoids are antioxidant in nature, they're good reductants. Therefore, the logic in using these carotenoids for reducing elements was on the basis of proper literature that was available. We also got the other type of surfactant that I told you, this glycolipid, which is produced by the organism, was able to give us extracellular. So for the previous one, it was all intracellular. Carotenoid that is present in the cells was actually bringing about the synthesis of those nanoparticles. Here we got an other product, that is your emulsifier, which was a glycolipid, and that glycolipid mediated the synthesis of nanoparticles. That's another picture, maybe more clearer picture, showing you that Gordonia actually is orange in color. We understand the importance of carotenoids because of the orange color. It's visible. Okay, so this organism has the orange color pigment. And we actually, she went to the petrol pump, brought back some soil samples, isolated this, identified this. So this must possibly is the first paper that we presented, wherein, you know, we identified the culture and we showed that it is very good in synthesizing nanoparticles. Now these are images that you will see. UV visible spectra showed you that it could synthesize gold and silver nanoparticles. That is your TM images showing you that there are indeed nanoparticles in there. FTR spectra telling you what are the kind of groups that may be involved in the nanoparticle synthesis. And we boiled down to something called as a glycolipid, and we did a lot of characterization of the glycolipid that was there. We identified that, can you see this band out here? And then we able to scrape it out. It was a glycolipid, and we were able to show the functional groups that were there. We also were able to identify glucose as a part of this, and 3 fatty acids that were present. We got the purified glycolipid. Can you see, just monodispersed? All of them are of the same type, as opposed to the previous picture. Can you see, these are all polydispersed? Big ones, small ones, small ones, small ones. But if I take the purified compound, it is known that if you take a purified compound, you'll get more monodispersed kind of things, as is evident from this picture. Can you see, all of the same type, or even this one, more or less of the same type? Again, we propose that since it is a glycolipid kind of thing, the glucose moiety that may be there under alkaline conditions may be converted into gluconic acid. And when it in the presence of your ionic forms of gold or silver, it converts into the elemental form. And that's how we propose that this would be the way by which this must be happening. There was one interesting study that was also carried out with another strain of this Gordonia. This is called as Gordonia ameri, and this was published in Sensors and Actuators. I would like to make a special mention of Zainab and Rutuja. They were students who had come to me for their master's project, and we put them onto this task. Somebody from a college, Garwari College, they came to me and they said they want to do a master's dissertation, and we did this work, and the outcome of this work was so good that we could put it into a journal called as Sensors and Actuators. And this has an impact factor today. This day before yesterday, I was updating all of these. It has an impact factor. For a student from a college who's on a master's dissertation, having a paper in impact factor 8 was something really, really creditable for them and also for me. I can boast of such kind of things whenever I visit out here, and gives me a very nice feeling that yes, everybody has a lot of potential to do a lot of things, and if you're given the correct direction, we can really do very, very well. Is that message I want to take. Now, this particular organism also was there in the laboratory. It also synthesized nanoparticles. This is all like your previous pictures. We showed that it can synthesize gold nanoparticles. We optimize conditions. The beauty here is not the synthesis, but the application for sensing copper. Okay. What is the logic for sensing copper that we said? We did a lot of literature survey and we found out that you have dispersed gold nanoparticles. Say this is a pictorial representation that is also there in the paper. You have cysteine with a SH group that is there, and you have these dispersed nanoparticles. The moment you add this cysteine, what happens? It becomes aggregated. The SH groups can just bring about aggregation of these gold nanoparticles. So if this was pink in color, this will be purple in color after aggregation. This is in the absence of copper. What happens in the presence of copper? You have such kind of cysteine being formed. So your available SH groups are no longer available. They come together and form the cysteine. And then you have cysteine plus copper, cysteine plus copper plus dispersed gold nanoparticle. The copper will interact with this and give you this kind of a complex. This is still available and the free form. So we could use it for selective sensing of copper. That was the beauty. Therefore, it went into the sensors and actuators. I am a trained microbiologist. Okay. So it's very, very important for the students to understand that we must deviate from our basic. I have great pride in publishing in a microbiology journal also and in an interdisciplinary journal. It gives you a different kind of a pleasure to do both those activities. So we were able to work out all the ways by which we were, we varied the content of the cysteine. There were all optimization processes that went on. And the end of the exercise, what you see out here, maybe in the B picture, you can see that selective detection of copper ions. One is the control you have incubated with cysteine, wherein you get that aggregation. And whenever there is copper, this copper will interact with the cysteine, and you get only the pink coloration. So that was the logic in developing this kind of a sensor. You have these aggregates. When there is cysteine, it is non-aggregated in the absence of the copper. And then if you can see that it's very, very selective for one. One is copper. Only here you get a pink coloration. All of the places you have a purple coloration, okay, which means it's very selective for, from my experience, I understand that nanoparticles of microbial origin can be very, very specific for particular reactions that are there. So we did a lot of optimization and all of these parameters. My student was keen on saying that, yes, I want to show that in serum, we should be able to do it. Then she found out that there are certain, what would you say, disease conditions where copper will bring about a change in some, body structures and things like that. And then we found out we took serum, we fortified that with copper and extended all these studies to biological samples also. We were able to effectively demonstrate all of that. And we got this paper. So I'm coming to the close of this particular presentation, just with a summary slide. This is just 1%. You'll see everywhere there is the student. All right. This is Harshada everywhere. This is for the students. All right. Anybody who's here wants to do a PhD, wants to do anything in life, you must keep such kind of examples in front of you. You have 2 good reviews. What are the journals? Critical reviews in microbiology. Impact factor 6. You have a lot of citations. Remember, all reviews will have a lot of citations. The second one is biotechnology advances. Impact factor 12.1, citations 33. One book chapter. So that becomes a part of your introduction. All right. Then you have one paper on degradation of squalene, of diesel, of silver nanoparticles, gold nanoparticles. 1, 2, 3, 4, 5, 6, 7, 8, all one PhD thesis. All right. And then this one was the other, those students who came from the college, and they were able to do, they extended their work. It doesn't happen in 6 months. They extended their work for a year or so, and we were able to get this very good paper in sensors and actuators. And these are kind of success stories I like to just share with students so that you get motivated to do something in life and do the best that you can for them. Okay, thank you very much for your kind attention. Out, go. So are there any biologists here? No? There, oh, great. Then should be lots of questions. Okay, fine. Take. Sure. We are already running. Sure. Yeah. Yeah. Come on here. Yeah, she's coming with a mic.
Hello. Hi. By the way, my name is Harshada, so thanks for giving me that. So anyway, my question is a little bit chemistry oriented, which is related to the last part that you shown. So you were able to selectively detect copper, right, with the gold nanoparticles, and using cysteine, right? I understand a little bit about chemistry being copper and sulfur have some soft interaction, like soft metal and copper, sulfur also being soft. Have you able, like, were you able to do something similar with another soft metal? I mean,
The panel that I showed you was with all the other metals that were there.
Yeah, so I didn't get
exclusively,
that,
this was more of the copper that we were able to see. Somehow that was just happening in that way. I showed you that whole panel, wherein if you, I've had to rush through that, but each of these were different metals that we were trying to see.
Okay, and they were
so
soft metals.
exclusively for copper, we were somehow able to get that kind of.
Okay, that really is then interesting
Yeah,
because
yeah.
something just came up, whether it's a soft interaction.
Yeah.
You could have some other soft metals
Yes,
also.
but
right?
now this one, we had that whole battery of metals that we were checking, and
Okay.
somehow it was very exclusive for this. But
Okay, thank you so much for
Yeah.
answering.
okay.
I request participants, if you have any questions during lunchtime, ma'am will be available with us. You can ask some questions. Because of lack of time, we have to move ahead. Thank you, ma'am, for those for that great information. And I request Dr. Niluma Rajukar, ma'am, to kindly felicitate Honorable Dr. Smita Jinzade, ma'am, with the Certificate of Excellence, memento, and bouquet. Thank you. Without wasting much time, let us go ahead. May I call Dr. Mohini Gupte to kindly introduce our next speaker, Dr. Bikash Aish, who is the Managing Director of Avanira Group, Pune. Dr. Mohini Gupte, please.
Thank you, ma'am. It's my pleasure to introduce the speaker, Dr. Bikas H, MSc in Medical, PhD, and MBA, a different combination. Dr. Bikas started his scientific career as a student of medical pharmacology from BJ Medical College, Pune, and completed his MSc in medical. He initiated research in the area of herbal antibiotics from University of Pune and completed his PhD from Department of Chemistry, University of Pune. He also was conferred with the degree of MBA in marketing from Institute of Management and Education, Pune. Dr. H has substantially contributed to other research programs, including molecular characterization of microbes, participating in degradation of rocket fuel waste. He has vast experience in bioorganic and herbal research. His expertise are experimental pharmacology and lab management, bioorganic chemistry analysis for small molecules elucidation, toxicological and xenobiotic studies, preclinical and animal modeling experimentation, and microbiological screening. Dr. Bikas has served the academic community as a lecturer in pharmacology for pharmacy as well as various medical colleges. In his capacity as an MBA, he has provided valuable guidance to several pharmaceutical companies. He was closely involved in Science and Technology Park's incubation activity as an incubatee for more than 6 years and as a joint CEO, Growth Lab Business Incubator. Dr. Aich is an entrepreneur, initiated a biotechnology company called Gene Biotechnologies Pune, and his passion for the chemical and pharmaceutical analysis have helped him to achieve another successful landmark by setting up Avanira Biotech Private Limited, Pune, which is a highly equipped with latest analytical and development instrumentation lab totally dedicated to the development of environmental analysis and biotechnologies related to the environment and small molecule developments. He has, to mention a few achievements, Dr. Bhadkamkar's Award for Best Paper and Research by Research Society, Western India in 1995. The first ISBA Award, Indian Steps and Business Incubators Association for the Best Entrepreneurship in the Biotech segment in 2008 and 2009. I welcome you, sir. Thank you. An apt speaker for the session today. Thank you.
Good afternoon, everybody. I am very much honored to give you a small lecture in ISS. Actually, today I am in between my teachers and my colleagues. So, in the morning when I saw the list of speakers, I was a bit really nervous because I'm going to talk in front of my own teachers. So, thank you for this opportunity, Rajukar madam. Really, I mean, it's a though my because of these industries and all, time is so difficult for me, but I said that I will make it today. Since morning, I was actually listening to the beautiful lectures, especially related to the analytical techniques and microbiology and all. And I am related to both the areas and jack of all traders. So, so not in very particularly into the whole situations in any of this particular subject. But anyway, I know how to link them very well. So that is exactly Avanira Biotechnology or Avanira Group is doing. Avanira is actually a group of company where we do everything right from calibrations to testings of different biological as well as chemical testings, which is situated very nearby in Chinchwad. So at this moment when everybody is hungry, so my topic will be a bit lighter. What I feel today is that promoting and marketing in analytical chemistry, because when I was told that there is a lecture on analytical techniques and all those things, and it's an interdisciplinary science, I thought that to bring ahead in between the students, my lecture is obviously made structured for the students and future. And so I thought that why not talk about something which is actually lacking in our country, to say so. To start with, I will put one statement which was made by one of our HOD, which I don't want to mention. But this is really very difficult to say, that I myself, as a student of University Pune, I myself went to many departments to procure different people from different divisions. Like we have around 45 people working. There are a group of 25 people in R&D and testing department, and rest are there in there is service department, there's marketing and sales and all those things. Now the thing is that when I talk about testing, I talk about quality control, I talk about your research and R&D and all. they are ready to produce students for this type of departments. But when I want somebody where we require to have a very good student, especially for marketing and sales, for technology sellings and all those, then I got a very bad answer that our students is meant for R&D, not for marketing. So it should not be that. That's why I said that I bring to you a very new window about how you are going to do into this promoting of marketing in analytical chemistry. So if you see the marketing and sales, when you talk about marketing and sales, it's very, there is something like that, you go to door and selling and all those things comes in your mind. But actually it is not the same. When you talk about analytical chemistry, you'll see that what we need are very, very competent people. And without those, you cannot reach our customers and meet our need of the high profile customers, which is there in the industries. So just now, as I was saying that throughout the morning, like somebody talked on different analytical procedures by nuclear electrons and protons. Then it came to how it has been managed to from biology to energy. And then just now, Madam talked about beautiful the properties of microorganisms which we can exploit. Now, when you talk about all these things, we come across these things only when we meet in scientific sessions. But I feel that this has to be taken to the ground. It has to be taken to the industries. So the only people who can do that is you, who is really understanding the analytical chemistry. You just cannot take up a person which is not related to this field and just tell him go and market this product. It's impossible to do those things. So let us talk about this. So the slides are only 15 slides. So I will go ahead with those slides very fast. There's nothing more than that. So research and development in analytical chemistry. So So when you talk about research and development, from here to number 3, industrial adoptions, the most important part which takes place is the marketing and sales. We talk about marketing and sales, but the team understands the needs of different industries and create compelling messages to showcase the value of them. I'll talk about few examples over here because most important is that they have to understand both the sides. It cannot be like a person who is not getting job anywhere, just come and sell a product because we don't not getting a job. Let me take up marketing and sales especially in this particular area, what do you call it as analytical chemistry, very high profile area. So knowledge is a knowledge-based marketing. The key to success is understanding the industry needs, value proposition, communication, and building trust and credibility. The first thing is understanding the industry. Here comes the absolute knowledge of your chemical science. If either a chemical or maybe biochemicals, chemobiological, whatever you say. So here it is required that the well qualified, in fact, sharp students, especially in analytical chemistries, they can have the opportunity to look into being a good marketing persons in this particular, because if you don't understand the need of the scientist, what you are going to market actually. So that is exactly the first point. Then value proposition, they should be clear. Articulate the benefits of using the analytical process. Sometimes it happens that we go to certain scientists or certain areas in industries where they're working in either in pure biology and they don't know what to do with the output or where to go and how to analyze the products. So then that knowledge is also required with these type of people. Then building trust and credibility by demonstrating expertise. So that is obviously the back end of that particular person, how he's going to promote it with his own company. Why understanding chemical analysis is essential. Quality assurance, very, very important, is going day by day. And that is why, in India now, you can see the products are, we are getting much and much better products, which is very, very important. And government is putting more and more stress on that particular issue. Problem solving, then analytical professionals can identify and troubleshoot complex production of issues. So that is where, again, we require good knowledge of chemistry. Without that, you cannot give on-spot problem-solving issues to your clients. Then regulatory compliances, very important. Where it is not required that we need to know all the regulatory compliances, but overall so that we don't mess up with certain type of products. And innovation and development. So now here you see there are a lot of things. I can give you an example. You know, I visit a particular company and they ask me that, can you do this particular thing? And then the person says, yes, yes, we can do it. Why? It's a metal testing, no problem. Coming back, it becomes a non-destructive metal testings, and then you don't have the facility to do it. So these are the small things. These are the critical things which analytical chemists should understand when they are into marketing professions. When you talk about effective communications building and stronger relations, the technical expertise, knowledge of chemical analysis is very important. Trust and transparency, yes, that is most important. See, everything you cannot do in one lab. I have seen people in sales and marketing, they just tell out, yes, yes, sir. This is, you cannot, I'm talking about molecular biology, biotechnology. Can you do this particular tagging and, fuse two genes for production of more proteins? Yeah, we can do everything. We can do everything. So it's the first thing which we should understand, that it is science. It can do it, but it is not that easy many a times. And we commit falsely because our knowledge is not right. So that is exactly what happens. I've seen students, sales guys in my company doing these things, and then we land up into mess with the customer, and that leads to very good picture. And then client satisfaction, obviously, when you talk about, it's not only the sales, the post-sales also, that we could really meet the client satisfaction by knowing the background of this particular work which you are doing. So it's not like the sales or marketing is over the moment the product comes to you, but it is more important that have you given back the required report to them. If you don't yourself, then how is it possible that you will promote this particular area? Now, when we talk about client communications, technical understanding, need assessments, solution presentations, and relation building is very, 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 very important. In each one of these, there is a 80% touch of chemical knowledge or your basic knowledge in analytical chemistry, and 20% is your handling of clients. So that is most important. So it is what I'm trying to emphasize in this, that in our agenda of teachings, like, you won't imagine there are few students which can come to me for many people, they're freshers, they come for the interview. And to say the things that many of the students not even seen that particular the instrument of analysis. So that is very, very difficult. MSc passed out students. So this is very, very critical, that we should understand, even for, I'm talking about even for R&D purposes, even for technical department. So you have to understand that whatever we're doing now, please do it very seriously, and it is equally as you are seeing the scientists or the technical people developing the products in their laboratories. The same thing, if you have to bring it to your clients, it will require super special people, which you require in marketing and sales department. Promotion, sales, marketing, different marketing strategies are there. We are not going to details of that. So, but in all these areas, the most important things is lead generations, which can be worked out as a telemarketing, or it can be on-site marketing. What is the best part? I myself has done a lot of marketing and sales. The beautiful part is that you meet especially in contract research, you meet different scientists and their need, and you understand, like, as if you are sitting in a conference and listening to so many speakers in different areas. So that gives a big opportunity for a person who is sales and marketing, technical sales and marketing person, so much. And I will tell you, when you talk about the technical knowledge, these are the technical knowledge which you really need. It's not like that I am into sales and marketing, मुझे याद नहीं है, मुझे मालूम नहीं है, मैं भूल गया. It's not that at all. We need people who in the industry needs people who are knowing these things. Don't need people who don't know these things. And you don't know these things and you come for marketing and sales. We don't need such people. We need people who know these things. They are equally, if I put the person into the laboratory, he can equally work there. But the thing is, it is more difficult to talk this with the scientists or with the people working in industry, other companies. So you are going to sell your services to them in analytical chemistry. It is not a product, selling product. It is not taking one product and tell, okay, this is the product. It is selling a chemistry, understanding your customer and giving some at your level, then yes, the confidence, you can do it or you cannot do it, whatever it is. It has to be very clear about it. Now, collaboration, and the most important, another thing which we see is that going to the market, talking to someone of your scientist, and then we come back. The most important thing, how you going to give the feedback to the technical team. So actually, sir, they want these things. We need to do this. We need to have these things in the market. So this is must, that is reverse analysis and reverse need creation or demand creations is very important for these people. So you can understand the knowledge of analytical chemistry for marketing and sales technical is very, very important. So meeting specific clients, pharmaceutical, food, and these are only few. There are so many areas which have opened up in last few years, niche areas. So the demands are going on increasing and increasing, and it is very difficult for analytical chemistry to serve those demands because many big, analytical techniques are also coming into picture every year. So these are the essential skills, and so marketing strategies for analytical chemistry, content marketing, digital marketing, all these places, whatever you talk, you need to have that particular balance of understanding the chemistry and understanding your customers. So career opportunities, which I feel, and I'll tell you one truth is I came to know from outside our country also, the marketing and sales growth, they grow much faster in industries. When you talk about career, you meet a lot of different people in your industries. You have opportunities and more, learning capabilities and more. And so that's why you grow faster, even monetary also. So I've seen that people in marketing and sales in other countries, especially in technical marketing sales, especially in this type of niche areas, they are the real good earners and compared to any other departments. So it's big, and if you talk about career opportunities, but you have to like it. That is most important. And conclusion, marketing analysis chemistry is crucial for translating scientific advancements into practical solutions. By understanding industry needs, communicating value propositions effectively, and fostering trust and credibility. Analytical chemistry companies can achieve sustained growth and contribute to advancement across various sectors. Very important because, see, whenever you are seeing since morning, three of our very eminent talkers, they have just now talked about their areas, but it is never possible under one roof. You have all the analytical procedures. So the linkers are the sales and marketing people, the both way. Your product to the market, your service to the market. When I talk about just now in the morning, I was saying that so many analytical techniques are available in nuclear. New techniques have come and old techniques are there. So many of them, even I was also not knowing. So because there are no people who can talk about it. Because when I was looking through those slides, I saw in all the three presentations where my company can contribute or can take or buy. So both the ways. So very important, students. These slides are not for our scientists over here, and it is for the new coming students. This particular lecture, I thought that I should take it to make you understand in technology of analytical chemistry, your presence in sales and marketing are all shoulder to shoulder to the person who is developing the technology inside the lab. Please understand that is very, very, in fact, you will be talking about these technologies in the right and perfect way to those much more efficient and specialized scientists. So you need to have a core understanding and knowledge about the subject along with there is a extra burden of along with knowing the skills of marketing. Thank you very much. If you have any questions, I'll end over here. You can ask me these questions. Thank you. or you can ask me during the lunchtime. No problem. Okay, thanks, sir.
Thank you so much, sir. And I can understand the great efforts you are taking to introduce this particular area to our students, that they do have scope in this area also. Probably they don't understand. So thank you for giving this insight. Friends, I request Dr. Raghav Saran sir to kindly felicitate Dr. Vikash Aish sir with his Certificate of Excellence and memento. So we are at the last session of this morning, and we obviously extended to afternoon. And the last lecture will be taken by Dr. G.C. Grover, Safety Advisor and former Chief Scientist, CSIR NCL. May I request Dr. Narendra Gokan to kindly introduce Dr. G.S. Grover.
Yeah, good afternoon, everybody. Yeah, it is my pleasure to introduce Dr. Grover. Yeah, Dr. Grover has been a chief scientist, Scientist G at National Chemical Laboratory, NCL. Everyone know about it. He earned his BSc and MSc from Delhi University and MS Chemical Engineering from University of Salford, USA, UK, and PhD from Pune University. He has more than 30 years of experience in research and development activities related to development of processes for high pressure catalytic hydrogenation and oxidation reactions. Dr. Grover has several research papers and patents to his credit. So besides undertaking scientific research, he also aided the organization in management as a head research planning and audit unit, and also head safety management. Then he has obtained specialized training in safety management from the UK and Denmark. Then as a safety manager, he has represented several organizations like NCL and CSIR at many safety meetings and conferences both in India and abroad. He has been an active member of the Pune District Crisis Group for Emergency Management. And other than this, Dr. Grover has delivered lectures on various aspects of chemistry and laboratory safety at National Safety Council and in various educational and industrial organizations. He has also conducted full-day workshops, trainings, courses on the subject. Dr. Grover has also held training campus and brought about awareness on chemical and general safety to school and college children in rural and urban areas in Western India. He continued to conduct safety orientation programs in virtual mode as webinars for several colleges during the COVID period. So Dr. Grover retired from CSIR NCL in 2015, and subsequently has helped this Indian Institute of Science and Educational Research, which is ISAR in Pune, in toning up and adding value to the safety group. At present, he is associated as a safety advisor with educational, technical and research institutes in Pune. Then Dr. Grover is a safety training program fellow of IUPAC and has to his mandate to undertake safety awareness programs to improve safety, health, and environment in academic and research laboratories in India. Then he was the task force chair to the IUPAC safety training program in India Regional Project 218. And lastly, he is an ardent champion of laboratory safety at the and as an IUPAC fellow continues to be be active in lecturing and offering safety training program to universities and colleges in India under the IUPAC safety program training as Asia Project 2024. So without further delay, I would want to invite Dr. Grover to present his topic on safety seedlings. Over to you, Dr. Grover.
Thank you, Dr. Narendra Gokan. And I'm so glad to be present here today, although it's the last talk of the day before we break for lunch. But as probably destiny would have it, my slides are not opening up. So maybe we can give her some time, maybe 2 minutes more. Otherwise, maybe we'll break for lunch. Maybe that's the best way to do. What is your opinion on that? Although I can speak, but then you know, the combination of slides and some photographs and it's not opening up. I don't know why. Maybe somebody can help her. Sorry. Uh, well, I would. Okay. Okay. Any probability? More than 50%? Ah, that's good. See, that's being very, very positive. Okay, we had okay. At the outset, let me just thank Professor Nilima ji for having invited me here, and I'm so glad to be present here in the presence of distinguished, guests, audience. Now, when you talk about safety, I thought maybe we'll just begin with some of the general concepts of safety. Safety is something which people at times feel क्या करना है सब ठीक तो चल रहा है आज तक कभी कुछ नहीं हुआ these are the kind of feelings that people generally have about laboratory safety and things like that. Okay. And particularly so, we are in an audience, we are in a group of analytical chemists. When you talk about analytical chemists, I really don't mean chemists. See, when you talk about analysis and the services that this group provides, it can relate not only from chemistry, but biology, life sciences, X-rays, atomic energy, radiology, and whatnot. It comprises so many things. But then, does that give a sense of being, aloof, satisfaction, saying that, look, nothing can go wrong with me? I think that kind of a sense is something which is not right. Wherever you are, if they are chemicals and they are machines, if they are sophisticated machines, well, yes, there's a possibility of an error, man-made error or error by somebody else, and there could be a possibility of an incident or an accident which can harm the institute or yourself. That kind of feeling, I think we must get away with. To just give you an example, maybe about a year and a half ago in Bombay, in one of the standard analytical institutes, there was a big accident. It went wrong. Something went wrong with the machine. At times when the accidents happen, they happen, one after the other. It forms a cycle kind of thing. 2 ladies, they lost their lives. They were burnt not because of fire, but because of the chemicals splashing on them. Well, that's something which I felt that, look, we must feel that, look, it can happen in any atmosphere. Well, that's a analytical laboratory. We talk about instruments, we talk about surveys, we talk about supplying instruments and all that. Well, in many of those, in the institute where probably I go once in a while, maybe about 2 months ago, there was an incident there also. A vacuum oven was supplied by a supplier, kept in one corner, and the day of installation, 2 people started lifting it, and on the way, they didn't do any site preparation. On the way, somebody hit the oven, just was kept below. Then they took it to the room. Again, the site wasn't prepared, and ultimately, what happened with the weight? It just dropped, and one of those
gentleman, he lost tip of his finger. You know, accidents can happen anywhere you go. But then we must make sure that, look, these do not happen. How do we make sure that, look, these do not happen? There's something called, you know, when we talk about safety, we call about unsafe conditions and unsafe practices. Accidents happen because of these two things. Unsafe conditions are something, you know, there's something inbuilt in the organization or in the setup that you have, which organization can, of course, set it right. Like when I'm walking here, if I wish to come down, there's a wire here, you know. It's not really safe for me, but in case I've noticed it, I'll take care of myself. But then somebody else could have fallen. There was a trap and somebody could have fallen there. Unsafe practices are something which you feel that, look, you yourself do it in a wrong way. You may feel that, look, you are doing the right. You may take a shortcut, but then that's not right. There's so many examples I can give. You know, you said that, look, let me share experiences that you have. All these things can be set right by reading a lot, reading standard textbooks, and being a part of, you know, proper, authentic education and training. Training is most important. And of course, you must understand what is right, what's not so right. What do you do about them? You know, I just ask a simple question. When you're walking along a road, maybe not too wide road, but then there's no footpath. Which side of the road do you walk? You're moving forward. Which side of the road do you walk? Anybody? It's fast. Time is less. All of us are hungry. चूहे दौड़ रहे हैं. Left. How many of you agree? Well, yes. The answer is not right. The answer is you must walk on the right side of the road. On the left, in India and many of the countries which are Commonwealth countries, we drive on the left. Okay? But when you're walking, you must, and if there's no footpath, you walk on the right side of the road. Why? You are walking, the traffic is moving from the right, left, and you can see the traffic come from the forward side. He can see you, you can see him, you can take care of each other. Well, yes, this is something which is called training. You have a bottle of ammonia, okay? Most of us, what do? Go to the laboratory, take a bottle of ammonia, tuck, 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 pull the air. But then that's not right. People have to be told that, look, how a bottle of ammonia has to be opened. It's pressurized. It's a liquid which is saturated with ammonia. And when you open it, it's like, you know, any Pepsi, Thumbs Up, Coke bottle, it fizzes out and it can fall on your face and eyes and things like that. I think it requires some kind of a training. So what I was about to sort of present, but then it's okay. I'll continue with my experiences. How do you get educated? How do you get trained? Well, yes, you talk about chemicals. First of all, you must understand the chemicals. When you say understand the chemicals, आप देखो उसके बारे में. I mean, what are the properties of that chemicals? Where do you get the chemicals? Where do you get the information about those? Well, yeah, as simple as that. Material safety data sheet. But then today, we have the, you know, universal Google Pandit with us. Tuck, 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 tuck. You know, key in some words, and immediately within less than 10 seconds, maybe you can get 250 references or, you know, sites which you can open and get the MSDS. MSDS gives you the hazards of that particular chemical, the first aid measures. You know, it's a big 16-point format is there. You come to know about that particular chemical. Besides that, you also come to know about that chemical from the labels that you have. Okay. We have a bottle of mineral water here. Read the label properly. I don't think we have ever cared to read the labels of something. Read it. It'll give you so much of information. You have a drum of acetone. Okay. Read it. It shows you a sign. It's flammable. You have a bottle, you know, whether it's Aldrich Sigma or, you know, Ranbaxy or whatever chemicals you're buying. There's always a small label is there. And there's a pictogram. And there's something written greatly on that. I was to give an example of acetonitrile. If somebody cares to read about it, the first line says, it may cause cancer. How many of you know about it? If you don't know about it, not that I'm scaring you, but then you must get a priori information about the chemicals that you're handling, the hazards that it has, and how you can get away from those hazards by doing some kind of a risk assessment. Okay. Risk assessment is something like which I did today. I brought this pointer and a slide changer with me, thinking that, look, in case the organization probably doesn't have it, well, I'll have it ready. If it is raining outside, if you have an umbrella, you can walk, you can straight away go. If you don't have, maybe you don't have. That's what, you try to see what is missing or what can go wrong. Prepare yourself for that. This is what probably is risk assessment. When you talk about hazards, I was talking about the signs and symbols. Many of you probably would have seen the signs of symbol of, like something flame going up or something with a skull with the two bones here. What are these signs? I believe all of you would know about it. Something, there's a sign which you see even on a petrol pump, flame. What bells ring in your mind? I generally, when I approach people, I try to sort of, people know everything. You must wear a helmet. People say, wear a helmet, do this thing, open this door, walk slowly. When you're walking down the staircase, hold the railing. I don't think any of us ever reads it or ever does it. I was about to say about that sign of that flammable material, What is the bell that rings to you? So you ask someone, ye kya hai? Flammable hai. Ye bottle of don't get flammable hai. But then what do you do? And what do you not do? See, if it is flammable, you certainly cannot keep the bottle open. You cannot keep in a bottle, you cannot keep the bottle open there. You cannot pour it down a beaker and heat it. You cannot do all that. It's going to, the sign indicates that it's going to catch fire. Its vapor is going to catch fire. So you have to see that, look, it doesn't catch fire. How you can see that? There's no flame around. There's no source of ignition around. These are something that probably things should, tinkle in your mind. You see a sign when you're going on the road. As soon as you reach a crossroad, of course, if there's no traffic, there's a traffic lights are there. The moment you see the traffic light, you see the red light. What comes in your mind? I have to stop. This thing has been imbibed in us right from our childhood. Red light means stop. Green light means go. Similarly, about chemicals also, in case there's a toxic chemical, if there's a flammable chemical, if it's an explosive chemical, okay, as soon as you see it, it must come to your mind that, look, I have to be careful. And how you have to be careful? You have to imbibe in your mind. You have to train your mind. It doesn't come by itself. You have to train your mind and think that way. I give you a piece of paper. Okay. I give you a piece of paper. It's all white. There's a small black thing in between. I put a cross and I ask all of you, what do you see in this paper? I'm sure 90% of the people will say, oh, uske upar ek cross laga hai. But then why don't you see the whole sheet except this cross is blank? You can write anything that you wish. You can write your story. You can write your publication. You can write your paper. Write whatever you want. Basically, what I mean to say is you have to train your mind to think in a particular way. Similarly, when you're in a laboratory, you have to train your mind to do the right things. Accidents do happen. Accidents happen everywhere. And accidents happen due to a combination of many, many factors. They could be uncontrolled. They can happen. But then when you understand chemistry, when you understand chemicals, when you understand instruments, the chances or the probability of you doing a mistake are minimized. And in case, for God's sake, in case something happens or something goes wrong, the damage that will be caused to you or the institute or the infrastructure will be minimized. Professor Saran asked me about to share my experiences. I have been sort of advocating about safety. My basic things are I'm a chemist and a chemical engineer. But then it is always through my personal initiation that I was handling safety, and the laboratory recognized it and gave me the charge of, look, besides doing your science and other management, you also take care of safety. Well, yes, it has to be taken that way. It has to be taken that way. Safety is something which you must understand, and see that, look, the probability of accidents are low. I was trying to sort of relate my stay in NCL. You see, if there were slides, I would have known that, look, I'm on the 10th or 11th slide. Please, any one of you can stop me, tell me that, look, time is up, and let's all proceed for lunch. Okay. When in NCL, okay. Okay, actually, this is what I was telling, in the short span of 30 minutes, I just cannot cover everything. Okay, yeah, I know Pune University has had an incident with sodium metal. When somebody, what they did was sodium metal is pyrophoric, okay? As soon as it comes in contact with water, it liberates hydrogen and that catches fire and everything just goes put. So basically, how do you handle sodium is you must always keep it in a non-aqueous medium, paraffin or glycerol or whatever it is. But then it did happen in Pune University once. Some of the students, I believe accidentally, I don't say anything else. It had happened in NCL. Okay. Anything that's pyrophoric and reacts with water, okay? When you talk about disposal, you must understand that, look, how do you dispose of things? You have a hazardous material, you convert it into non-hazardous, and then probably you can handle it the way you want. Most of the chemicals and solvents which are flammable, the trend these days is not to sort of, take up those activities in the laboratory. But then what do is you collect them, all the flammable solvents and other materials, you collect it together and give to a third party, which takes care of it outside the city limits and, either burns it in an incinerator, which is a safe way of doing it, or transforms into something else. There are a lot of people who sort of, waste solvents, they sort of put in a distillation column, recover it and sell it to the paint industry. They may charge you as well, but then they are also making money, but then it doesn't really matter. Let's not worry about what others are doing, how much money they are making, as long as our problem is resolved. When you talk about disposal, besides chemicals and other things, there are certain things like, you talk about in biology, you talk about, sorry, gel and all that. I think there are standard ways of handling it and disposing it. One is, of course, in case you can avoid doing them. The other one is gel with, I think you dispose of with bleach. Yeah, isn't it? You dispose of with bleach and then either, I don't know, I'm not too sure because I'm not a biologist. Either you autoclave it first or autoclave it later. And throw it off. Basically, it's basically converting a hazardous material into non-hazardous materials. In the laboratory, we also use acids. Acids are used in laboratory at a large level. Okay, what you must do is you must dilute and try to sort of neutralize them, make them neutral, and then probably you can flush them off. When you are flushing them off, there's only one thing that needs to be taken care of is for 1 liter of your neutralized solution, you must put in at least about 20-30 liters of water. It gets further diluted. Okay. When I was talking about wow. Thank you, gentlemen.
सेफ्टीचं ट्रेनिंग घ्यायचं का
बेटा तुझे सलाम. गाना तो है माँ तुझे सलाम, मैं आपको बेटा तुझे सलाम कहूंगा. Okay. Can you just okay. That also give me some satisfaction and also something like which is slightly organized way of okay. What I was telling was in an environment of routine analytical setup, the process and procedures do not have a high hazard index. However, accidents do happen. I gave an example of a Mumbai. I was wondering how many of you know about that accident in Mumbai? I won't name the company, but it was terrific. And on top of it, there's one thing which I thought I must definitely mention. The lab manager, there was a FIR against the lab manager last year for having not provided information, guidance, and safety equipment to all the people. 2 of them died because of burn injuries. The remaining had almost about 30 and maybe 25% burns. I believe people know about what happened in USA in 2009. One of the in University of California, one of the chemists, he was using Trishbutyl lithium. She again, Trishbutyl lithium is a highly flammable liquid. She was trying to sort of inject, maybe scale up the particular reaction which she had done a couple of times earlier. But then the way she was handling, apparently she added too fast. The syringe that she was using gave a back pressure and all that thing fell on her. She was burnt. She was not wearing an apron. She was not wearing safety goggles. She was a Pakistani lady working in University of California. She died after about a week. And in US, laws are very, very tough. A professor, Professor Allen, he was charged. He was charged with so many counts that apparently he lost his job, but then university also had to suffer. But then see, at times and at places, many of these accidents, they act as eye openers. Many rules and regulations followed as to what you should do, what should not do. Like what happened after Bhopal 1984. So many rules were there. That's okay. All right. Okay. When you were talking about instruments, what I was saying was many of the instruments that we handle or many of the situations that are there in the laboratory, I think we must be careful about it. Okay. I'll straight away come to that. See, this is what I was telling. Solutions are there. What you must do is all chemicals and materials can be handled with safety if the hazards associated with that chemical are known. Well, yes, you assess the risks, control them, and then maja. Everything is fine. This is what the MSDS gives you. Fire is the most dangerous of the hazards. Toxicity is there, but fire is the most dangerous of hazards. In Pune, in case you have been there, you have seen so many fires. Way back, NCL, there were 2 major fires. ISAS, there's such a major fire. Other places, so many fires are there. They destroy the whole departments put together. You are aware of the fire triangle. There's a symbol called fire triangle with 3 nodes, fuel, air, or a source of oxygen and source of ignition. In case you cut any one of those, you have it. And this is what I was telling you about, okay? This is a flammable thing. What comes to your mind? Yes, it's flammable material. I have already talked about it. Good safety practices. Well, yes, this is something a must. Safety goggles is a must in all areas where chemicals are used. When I say must, aprons we all wear. शौक से पहनते हैं. Apron पहन के दूसरे डिपार्टमेंट में भी जाते हैं, कैंटीन में भी जाते हैं. But then that's not right. All the safety precautions, personal protective equipment are meant to be used in the lab only. As soon as you come out, you remove your apron, you remove your gloves. I think today there's a fashion that look, we use those nitrile gloves, purple gloves we use in the laboratory whether it's required or not. अच्छा लगता है. Gloves पहन के, you go, pick up your water bottle, drink water, pick up the phone, start writing notes and this and that. That's no way. Gloves are something which are already contaminated and you're spreading the contamination. No. Gloves should be used only when you are handling a chemical, otherwise remove it. When you talk about training, look up some videos and try to understand how do you remove the gloves also. There's a absolutely proper way of removing the gloves. Not like something, this is contaminated. मैं यहाँ से पकड़ के ऐसे उतार दिया. No. That way you are contaminating your hands again. There's a proper way. That's what I said, training. Shoes that give you full protection. No sandals. No, beach shoes or things like that. In case anything falls on your feet, it's going to burn your feet. And that's the end of it. You may not be able to walk also. Of course, here, this is again something which is very, very essential. Ladies, and of course, if I have a beard, should not keep long hair flowing while you are in a lab. Here is something, there are 2 dangers. One is entanglement with anything that is around that's moving. If you just log on to Google Panditji, it'll tell you that, look, how many people have lost their lives, how many women have lost their lives because of long hair. It gets entangled in a vacuum pump. It gets entangled in, a small buggy ride. In Chandigarh, it happened. It happened in Singapore. One of the ladies, while she was trying to remove her baggage, it happened. I was talking to somebody in the institute where I go. I was talking to somebody that, look, I told her, I'll change the name. I said, Anita, अपने बाल थोड़ा ना कर लो. आप ऐसे करते हो, बनने लग जाते. No. I remember my hair had burned from the forehead when I was in Pune University while I was doing an experiment. Well, yes, if in case you know that, you have experienced that, you are one of those victims. Lesson कब सीखोगे? So this is something, and there are some OSHA guidelines to that. No smoking, no food items and all that is okay. This is something which I was telling. Apron, of course, goggles, and if required, wear a visor also, wear a visor. Well, it's good. It'll protect your full face and eyes. Well, yes, very important. As I said, know what to do. I was trying to give examples of what are the things that probably we do in laboratories which are not so safe. There are 2 things, as I said, 2 aspects. One is understanding the chemicals The other is understanding the procedures, how we do about it. Chemicals, ठीक है, MSD has ले लिया, risk analysis कर लिया. You know, you try to solve, to some extent, we say you have become slightly wise or wiser. But then what we do inside the lab, let's just see. Look at this. Clamp and Boss. If you walk into any student's lab or even a research lab, look at the way this is posted. It's a wrong way of doing it. 8 out of 20 will have this way of putting a clamp and boss. This is the right way. It's supported here. This is not supported. It can fall off. Isn't it a matter of training? Is it a matter of supervision? Students, research guides, masters, teachers, सबको देखना चाहिए. Well, yes, they have to be trained. Okay, look at this, burette. Simple things, what we, see, why I'm giving these elementary examples is we grow from this, and what we have learned at the let's put it, KG, nursery, first standard, fifth standard, 10th standard, 9th standard, we continue to follow that, irrespective of what happens. Look at this. Although this lady, she's doing the right thing, putting liquid with a wash bottle, but then she's not wearing an apron, she's wearing a goggles, good. But then this way of pouring liquid is not right. It's shown here. When you pour the liquid, what we are told is burette must be either in your hand or clamped, and it should be at your eye level. Okay, it should be at your eye level so that you can see the meniscus and go ahead. Done. Everyone agrees? Next step. We make one titration. When we do the titration, either we do best of 2, best of 3. We have done one titration. Indicator aa gaya, color aa gaya. See the reading? 12.4. Fine. Now we have to do the second titration. We take another conical flask, add the liquid, pipette it out either by mouth, wrong, pro-pipetter, laga ke, add the indicator. Then what do? Most of us, what we do is, it has come at 12.4, we refill the burette and bring it to 0. How many of us don't do that? What is the need to bring it again to 0? It's simple arithmetic. Second titration can begin from 12.4. Go to 24.8. You have 2 concurrent readings. Am I not right? See, these are some things which you must understand. Try to sort of correct procedures. Okay? Gas cylinders in lab or instruments or wherever it is, gas cylinders are full of energy source, so much of pressurized gas. In case the wall breaks, you put the cylinder here. In case the wall breaks, short of time, I don't have that video. No, I don't have means I didn't put it. Okay. What happens is the wall breaks, the cylinder will go up in the sky, break the ceiling, go almost 100 meters away. I've seen that happening in NCL. Yes. Way back in 1991, there was an accident. 3 cylinders blew off. Far off places. So yes. NCL is a place where R&D is carried out, but then mistakes do happen. Look at that. You must carry it on a trolley. The cylinder must be what? Where it should be placed? It should be placed next to a wall, carried in a trolley, placed next to a wall and chained. But then these days, our people have become very smart. Very smart. Very, very smart. They put the cylinder on a trolley and then connect to the reactor. इसको chain कर दिया है. Cylinder को chain किया हुआ है ना. But then what about the trolley? It's still on movable wheels. In case something goes wrong, it will fly off. It doesn't serve the purpose. This is what I'm trying to say. You try to understand. Okay? Instrument. See, as it is, there are hazards present in the instrument. Well, of course, as it is, when I say most of the sophisticated instruments, they have an inherent safety mechanism. They are safe enough. But then, in case you do not follow the SOPs, what happens? We do not follow the SOPs, we take shortcuts, and then we have problems. This has high magnetic fields, handling of cryogens, electrical voltage, etc. Was this not enough that, look, you have to climb on this staircase? Staircase domestically fabricated, which is not more than 20 inches wide. Height is almost about 12 inches. While the average height of a staircase, how much it should be? 6 inches, not more than that. 5 inches or 6 inches, architects will tell you. But look at this, with both the hands occupied with the tray and going on top of it, somebody's, no, please. Wherever such a thing exists, change it immediately. Of course, you have the compulsion that you can't have a metallic staircase in a magnetic environment. I believe people are aware of it when you talk about magnetic environment. A couple of years ago in Bombay, in an MRI instrument, one serviceman was carrying a gas cylinder inside. He was sucked inside the MRI machine. He died. So what I mean to say is accident can happen anywhere in case you do not follow the procedures and SOPs. And in case, I'll come to that later, in case SOPs have to be deviated from, just don't do it by yourself. Think about it. Discuss with your colleagues and senior. Get an approval that, look, I'm going to do this. I'll give you an example. I'd been to Hyderabad once, a research laboratory. There was an accident. What happened? When you do a reaction in a RB flask, exothermic reaction, what do? You try to cool it. They try to cool it with ice. One particular day, ice was not available. क्या करेंगे? Reaction तो करना है, नहीं तो report कैसे जाएगी? So what they did was they got some dry ice. Put dry ice in that, the temperature went down to -40. And then kept on adding reactant B. Reaction didn't start at all because it's such a low temperature. Reactions are dependent upon temperature. It's an exothermic reaction, all right. You put ice because it should absorb the heat. But then after having added at the regular pace, they stayed away. The temperature went up and suddenly the reaction went to such a pace that the whole thing exploded. Deviation from SOPs. Please don't do that. Anything. I mean, I'm giving an example where there was an accident. Incidentally, I would like to request all of you. In NCL, I'd always said, and that was my mantra, irrespective of what the accident is, whose mistake it is, please do come and report to me. Nobody will be penalized. Nobody will be asked to stay outside the lab for 1 week. Nobody's salary or stipend will be cut. But then, on the contrary, I may even reward you that, look, you have come honestly and told me something about it. You know, that gives you an opportunity to analyze the incident, say, look, what not to do next time. Disregard for SOPs, few moods. Tell me when to stop. Few moods. Well, yes, few moods are meant to see that, look, you do the reaction safely in a hood so that all the vapors, they are sucked out, and you put the sash because in case of anything happening, nothing should come on you. But then हम दोनों नहीं करते हैं. सैश तो हमेशा ऊपर रहता है, ब्लोअर भी चालू नहीं करते हैं और फ्यूम के अंदर डाल के ऐसे थर्मोमीटर से टेम्परेचर देखते हैं. I tell them, look, why don't you buy a digital thermometer these days? Put the sash down. I didn't put the photograph there, but I have a photograph. It happened in NCL. There was a sash which was down, but then you see the glass, which is a tapered glass. It didn't break off. It just cracked and it was still intact with the hood. That saved your life, isn't it? Rotovapes. Rotovapes are commonly used all over the place. Okay, but then do we understand how much of vacuum to put for which solvent? There's a table or there's a graph. There's a theoretical understanding of how much vacuum will reduce the boiling point by how much. हम तो लगा देते हैं. So उससे क्या होता है? You put 80 degrees centigrade and you're trying to distill toluene under high vacuum. All the vapors will come down to your trap if there's a trap, cold trap. Otherwise, they'll come out in the laboratory through the vacuum pump. Please, please, please understand what you are doing. Okay. Solvents, flammable and toxic. Handling, storage, and disposal. I don't think I'll be able to spend no much of time. There's some misconceptions about emergency response. In case there's a burn injury, burn on the hand, either in the laboratory you touch a hot plate or at home you touch a pressure cooker. My wife touched a tawa yesterday. What do? What is the response to that? Bernol laga lo, soframycin laga lo, but the no misconception is you should put it under water, cold running water for some time. People say, no. Usme wo aa jate hain, fafole, in Marathi or Hindi se fafole, or you get, but then they are good. What happens when your hand or something is, arm is burnt because of excessive heat? The heat travels inside and there are layers of skin. As the heat goes inside, all the layers burn and that causes a deep burn. When you say somebody is 90% burned, what does it mean? It's the area and the depth put together. Okay. So if you put it under water, you see to it that you are stopping or you are, transferring the heat from your body or the skin back to outside in buffer. It doesn't burn. That's what you should be doing. Spillage of corrosives. In case there's a corrosive that's spilled on your hands, that's Cl, perchloric acid, nitric acid and all that. What you must be doing, sulfuric acid, wash What happens in case somebody spills sulfuric acid, concentrated sulfuric acid on his hand or body? We have always learned right from our 10th standard, 9th standard, sulfuric acid. What you should do? You should add acid to water, not water to acid. Okay, this is what we have learned, isn't it? We have a bottle of sulfuric acid. They say in case you want to dilute it from 32 molar, you want to bring it down to sort of 1 molar. You take a bottle of sulfuric acid or take some sulfuric acid, add water to that. Basically, understanding that, look, there's a lot of heat of hydration, so that heat doesn't really pump it out. But then this particular concept, some people have always, it's embedded, permanently embedded, like rock cement. There's an incident in Bombay and in Delhi, both places, and elsewhere also. Somebody, by mistake, spilled sulfuric acid. The bottle broke. He was going down the steps and he suddenly, tripped. Shouldn't happen that way. All the corrosives, all the chemical solvents and all that, they should be carried in a secondary container. You should have a bucket or a secondary container, so that even if something happens, the spillage goes down the bucket, which is a 20-liter bucket, and your solvent is only 5 liters. Right? It happened. There are some people who wanted to rush him to a safety shower, pani se nala do, but then there were other wise people. They said, no. Acid gira hai, pani nahi dalna. Well, yes. This is what I say, misconceptions. Misconceptions. Okay, I give you another example. Phenol spillage. Phenol is a very, very common reagent that's used all over in chemistry labs and biochemistry labs. In case there's a phenol spillage, what do? They are wise people, very, very wise people. Phenol is acidic, NaOH डाल दो. Phenol है, उसके ऊपर alcohol डाल दो, जल्दी से वो साफ हो जाएगा. But no, both these things are wrong. Body is not a place for chemical reactions. Okay? And in case you put alcohol, it'll try to sort of dissipate everything inside. It'll go into the body, and it's not corrosive, all right, but then it's also toxic. So what you must do is, again, wash with soap and water. And in case you have known the MSDS of that, you know the safety features, you know the hazards, you know what is the antidote for that. PG 200, polyethylene glycol, there's a polyethylene glycol 200 molecule weight, you apply on it, it's good. Hydrofluoric acid, bromine, I can give you hundreds of examples. You must know what to do in case there's a spillage, either on the floor, on the desk, or the bench, or on yourself. You must do that. Please, when you go back to your labs and you're working, make a list of all the hazardous chemicals that you have. And see, in case something goes wrong, how you are going to react, how you are going to save yourself. Save your neighbor also. Safety showers and eye wash. Generally, it's a place when people feel that, look, it's a corner mein laga hai. Dump this also, this also, this also, this also. And when on the day when, you really require it, you pull down the shutter, water doesn't come at all. Safety shower, eye wash mein pani nahi aata hai. But then this is something you have to do. Examples are endless, I said, but solutions are there. Arm yourself with authentic information. Authentic information, not hearsay, not what your seniors or colleagues have said. Again, avoid deviations from SOPs. Okay, if necessary, discuss. Train yourself to handle unforeseen conditions. Stay calm. When I say calm, it's very, very essential. Ghabrana nahi hai. Unlike, I give you an example, in one of my labs there, one girl, she was a trainee, all right. There's a spillage and there's a small fire. You know what she was doing? She was trying to call her. Dr. Ogle, aap kahan ho? And he was somewhere in town at that time. No, you have to raise, stay calm, try to understand what you do, and give a shout. I don't know how many of us give a shout these days. I think we have forgotten. In the era of digitalization, we have forgotten how to shout. Can somebody just shout from the end? Help, fire, bachao. Okay, I want to hear. Nobody. Please, please. एक बार नहीं 4 बार बोलना पड़ेगा जब भी कोई सुनेगा. Okay. Let's report unsafe conditions. In case there are some unsafe conditions in the lab, I think report it immediately. There are people to tackle it. There are people who can solve it. Always report accidents, near misses. Well, yes, in this brief talk, I have only been able to sensitize and alert you. Attempt to echo some of the common unsafe practices has been made. Many more aspects have been left untouched. The first and the last behavior, all accidents are preventable. Remember this. Well, yes, bear in mind, if we cannot ignore the fact that practice of chemistry poses, well, yes, it does. Yet, if we follow some ground rules, and we can practice chemistry safely. Gentlemen, I wanted a small video here, just for fun. I don't know. Can somebody put a double click? Oh. I don't think I can do double click with this. Come to this slide. Time is premium. Come to the second last slide. End में जाओ. हाँ. Double click पे जाओ. Click करो. Double click. No? It's not running. Or go to, I have this MPG4 file separately also. Can you just play that? No, in the same folder, there's a file. If we can, fine. Otherwise, let's forget it. Okay, leave it some other time. Maybe you keep trying. I'll move further. I'll say thank you. Okay, I think that's what I wanted to say. I would like to sort of thank the organizers, everybody here, for your being present. You are being, it's almost 3 o'clock. I spent more than 30 minutes. Thank you so much for being attentive. Stay safe. And of course, as I say, my name is Grover. My email ID, she will know. Anytime, any problems, any questions, anytime. Answers, I guarantee every time. If it is coming from email. Phones, let's not do. Nobody attends unknown calls. Okay? Thank you so much. And I wish you and your journal, you are celebrating the 2nd anniversary. Many, many more celebrations. Good research papers in it. And good luck to all. Thank you, Dr. Naren. Okay, you have been very instrumental. He is the one who coordinated, he just picked me up from, I don't know from where he picked me up. And it was just providence. It was just providence that I met him on a particular day. He said, look, Grover, yesterday only I given your name. Well, yes, good. Thank you. Thank you all. If there are questions, we can questions or, some discussions we wish to have. And I'm there for lunch, of course. After that, पेट पूजा, उसके बाद घर पहुंचना है. Okay, thanks a lot. And as I said, I basically am a safety training program fellow for IUPAC. All of you know IUPAC. And there are projects with them. I completed a project in 2018-19 when I was the ambassador for safety in India. Now again, there's another project with me from IUPAC. I'm the ambassador for, that's a project for the whole of Asia, 9 countries. And I continue to be, conducting training programs in India. In case anyone, any institute, wherever you want me, in Pune, outside Pune, within the boundaries of India, I can come and talk to you. At no cost. My travel expenses will be taken care of by IUPAC. So good for you. You take care of me. My travel will
Our
be
final
taken by
category,
IUPAC.
the kinds of accidents.
Thank you so much, sir, for sensitizing us for this great topic. We do know everything, but when we go in lab, many times we forget. And every time, I think someone has to give this dose and keep on reminding us that these are very important things. Thank you so much. Without wasting much time, I request Honorable Dr. Raghav Saran, sir, to kindly felicitate Dr. G.S. Grover, sir. Grover, sir, is getting felicitated with Certificate of Excellence, memento, and bouquet. Sir. Thank you, Saran, sir. Thank you, Grover, sir. Thanks a lot. Thank you so much. Now we'll break for lunch. We'll take a lunch break for half an hour. And exactly at 3:30, there will be poster session, 3:30 to 4:30. And 4:30, we are gathering back for the validatory function. Thank you.